putting devices and cables together, we want to be able to talk about some of the different network design principles. Find out next right here on IT Pro TV.
You're watching IT Pro TV.
All right, that's right. There are many different network design principles for us to take a look at. And here, of course, to help us out is going to be Mr. Anthony Sequeira. Anthony, welcome to the show. How are you doing?
Doing great, Ronnie. Thank you so much. Let's jump right in because we have a lot to talk about. And, you know, one of the things, Ronnie and I have both been teaching Cisco networking technologies and Cisco network design for a really long time. And one of the things that him and I have just taught over and over and over again, I know it like I know my middle name, Joseph. Anyways, it's the 3-layer model, or you'll often hear this as the classical hierarchical. And it took me a long time in my Cisco career to be able to say hierarchical, by the way. But this is the classic model. So we have 3 layers. We have the access layer, we have the distribution layer, and then we have the core layer. The first thing that I need to warn you about with this model is, if you haven't experienced this, you will. Different people love to call the layers different names. Like, Ronnie, do you have a different name for any of those layers, or have you heard a different name for any of them?
I've heard about them, but I can't really remember some of them, but I have heard different ones over, and even the idea of 3-tier, I've heard as, 3-layer model. I've heard it as, tier 3 models, you name it. I've actually seen stuff like that.
Yeah, multi-layer model.
Right.
Yeah. One of the ones that I've heard a lot for the access layer is the workstation layer. Now, you can see why they would call it the workstation layer. The access layer is where people connect to our network. That's why in this diagram, Ronnie and I show you some traditional layer 2 switches and then some wireless access points. So how are you getting people on your network? Well, you're plugging them into switches, or they're connecting over the air through an access point. So you can see workstation layer. I actually like that name because it makes us think of the people out there on their workstations connecting to the network. Now we move a layer up, and it's the distribution layer, often sometimes referred to as the policy layer. And this is where we have routing certainly taking place, but it's also where we do a lot of things like security. Like, hey, wait a minute, can this group of people over here access the internet? Can this group of people over here access this group of people over here? So a lot of security, a lot of quality of service, a lot of policy goes on at the distribution layer. And then we have the core layer. Ronnie, I often hear this as backbone. Yeah, the backbone layer. And Ronnie, it seems to me that there's probably one thing that's really important in the core, right? Speed. Yeah, I always used to say it's like real estate, right? Location, location, location in real estate. For us with the core layer, it's speed, speed, and more speed.
Right.
Yeah, because think about it. The core of the network is where there's this aggregation taking place of all of these different systems that want to communicate. You need to have enough bandwidth in that core for all of the different resource access that's taking place. Now, there's something that I want to express to you about this classic tiered hierarchical model, whatever you want to call it. And that is something that I didn't used to teach, and that is special to Encore. So I'm glad you're here. This model emphasizes what we call a north to south or south to north type of flow of information. And this is changing. In networks today, we're finding a more east to west, a side to side transfer of information. And I'm going to prove that to you in a moment. But just think about that, where this classic model really, when we lay it out, we think of traffic as moving from the south to the north and then from the north to the south. Suddenly, I feel like I'm teaching about the Civil War in American history. But so just be ready to be flexible here on really a paradigm shift.
Yeah, there's no doubt that as we start to see this as well, most of the time people don't realize where is it actually used. So if they start off in a small shop, they might say, Anthony, I don't see a 3-tier model that we've implemented. So why are we talking about it?
Yeah, they're probably in a
Right.
collapsed core, right?
Right.
Yeah. Look at this. So this is when you hear two-tier or collapsed core, what you're doing is you're simplifying things. Like Ronnie indicated, if we're in a small environment, it doesn't make sense to distinguish the distribution layer from the backbone layer. So under that model, we're going to go ahead and do an access layer that leads right into what we call the collapsed core of the network. Routing's going on in there. The policies going on in there. The QoS is going on in there. In fact, that brings me to a great point. One of the reasons we don't do this in a larger network is, remember we said speed was super important in the core? We don't want a bunch of security going on, a bunch of QoS going on, because that could add overhead. So you take the core and make it all about speed, and you do all that complex policy and security stuff at the distribution layer so that you can keep the core running as fast as humanly possible. In a smaller infrastructure, it's not as critical for you to be like, oh, we can't do QoS at the core, we can't do security at the core. It's just not that critical. In a smaller network infrastructure, the segmentation of those jobs isn't as critical. So we could just mash the distribution and the core together, and oftentimes you'll have a specialized device in your core of the smaller infrastructure that can do it all. It does the QoS, it does the security, it does whatever else you need it to do. We know that's one of the beauties of Cisco devices, is that one device can be a great firewall, a great traffic conditioner, a great router, a great switch, and the list goes on and on of what that one device can do.
So let's talk about that core just for a moment more, the idea of the collapse core. So sometimes those particular devices that are on the distribution layer and that collapse core as well can be like a layer 3 switch, right? In which we can actually have both the routing as well as the switching function actually in that. So sometimes we see it, and we always see it diagrammed with multiple devices. But Anthony, in a really small shop, we could literally kind of collapse that even down to a single device, and most people don't realize that.
Such a great point. Think about one of the most famous devices of all time from Cisco. It's the CAT 6500 or the CAT just 6000 series devices, the 6509. Those devices became so incredibly famous, and they're still running in networks today, doing a great job, even though they'll be end of sale and end of life for many, many, many years. That is like all about the collapsed core, as Ronnie indicated. In fact, that device, the 6500 series device from Cisco Systems, that device can do it all. It's a remarkably powerful switch.
Find out next right here on IT Pro TV.
You're watching IT Pro TV.
That's right. We are getting started in HA, and the person that's going to help us to define what that means and how we actually improve that, Anthony Sequeira. Anthony, good morning, and hopefully you're going to tell us what we're talking about here.
Yeah, this one is not all that straightforward, I find. There's a couple of points here about HA, high availability, and we're seeing it more and more just that way, capital H, capital A. And it's really something that we're going after more and more, especially with cloud technology. Cloud can really help us in the area of HA, but I'm getting ahead of myself already. Let's talk a little bit about what high availability means. And notice, wanted to remind myself to emphasize here, HA versus redundancy versus reliability. Okay. That's the thing that I find in the industry is often confused. First of all, redundancy. When we think redundancy, like how about redundant power supplies in a Cisco device? That's a great idea, right?
Yeah, multiple points, so we have no single point of failure.
That's right. One of your power supplies fails, the other one kicks in and starts helping you. Look at the redundancy that we have in this class right now. If I have a brain freeze, Ronnie starts talking. It's awesome. Redundancy is a component of HA. So that's the first thing I need you to make sure you can embrace. High availability is this massive like umbrella term. And one of the ways you get high availability, one of the ways is to do redundancy. So redundant power supplies, redundant links, heck, even redundant devices. You have like 4 routers acting as default gateways under a first hop reachability protocol type environment. That's redundancy. What is reliability? Reliability is not if it's there or not. That's a component of availability and high availability. Reliability goes deeper than whether it's there or not. It measures how well is it performing. So there is a big difference there. Ronnie can set me up with an environment where there's high availability, but he can let me know, look, if your main device fails, I'm going to do a backup device for you automatically, but your performance is going to suffer. So now I know in my head, okay, he's accommodating high availability, but he's sacrificing a little reliability to do that. So reliability, remember, I like to define it this way, and this is the most common definition. Just how well is it performing? There is a baseline of performance that we want. How are we hitting that? Are we hitting it or not? So that's the reliability component. So the next thing I wanted to talk about here with our students, Ronnie, is how to get HA. And one of the great ways to get HA is to use tried and true proven models. This reminds me of my dad building houses. So my dad blew me away when I was a kid because he built our house, like all of it.
Wow.
And I was just looking at this, and it was like a 4,000 square foot home that he built in the woods of Massachusetts. And I was just like, how did he do it? But then as I got older, not to take anything away from him, I realized that he broke it down into layers,
right?
Like foundation, framing, electric, plumbing, and he used proven models for those different layers. And that's exactly what we're going to do.
Now, before we get too far in that, why is it so important to use proven particular methods when I can come up with whatever method I want to, Anthony?
Yeah.
Why would I care? If I just get it done, I get it done. What does it matter?
Yeah, you're probably going to run into things that don't work when you make it up yourself, and it can be really difficult to troubleshoot because you're like, well, I slapped it together and it works, but then when it's not working, you don't have any guidance on how to troubleshoot it. So if we stick with tried and true proven models, they'll probably have high availability built right in, and they'll even have like troubleshooting techniques well documented.
All right, so let's go back to that word the words high availability again. Now, generally when I've actually read about it, I've always seen it in terms of something like a service level agreement. Is that really what we're talking about, like that 99.9% of stuff or something like that?
Yes. Yes, there are a ton of different ways that we can measure HA.
Okay.
And the most common measurement is our 5 nines or 6 nines. And we're talking about the uptime.
Right.
Or if you're a glass half empty kind of person, the downtime. So like what is 5 nines? You're down like what, 30 seconds a year or something?
It's a little bit under 5.26 minutes.
Okay,
is what it
so
comes
the
down
5
to.
nines is in minutes.
Yeah.
When we get into like 9 nines,
seconds.
we're in seconds. Yeah. And those are the kinds of uptimes that cloud services can bring to the equation. But the whole 5 9, 6 9, 7 9, that's not the only way to measure HA. Another very common measurement is like mean time between failures. And that's a cool one. Like, okay, we know this device is going to fail and it's going to be unavailable at some point. But if it's like 30 years between failures, we can typically live with that. So lots of different ways to measure it, Ronnie.
All right, so I didn't mean to interrupt your flow that we were doing there, but I think it's important that we set that into context because more than likely as people read, they might go, well, we've talked about it in terms of number of devices and we talked about it in the performance, but maybe that concept, especially when they read about it in the first time they see a service level agreement, they might not have that understanding of how that all relates together. But
Yeah.
thank you for helping us do that.
Yeah, no problem. And you didn't interrupt my flow at all. The only time my flow gets interrupted is when I'm rapping, when I'm in my rap flow. Yo, yo, HA, it's the way to go. Don't interrupt my flow. Okay.
All right.
So there's services, Ronnie, too.
Yeah.
Oftentimes we think of hardware that's promoting HA, but there is services too that are going to help us. So I want to encourage you to take advantage of those. One of the ones we're going to look at together in this Encore show is IPSLA. The IPSLA is a service that can help us with high availability. So we want to target services that can actually help us in this regard as opposed to hurt us. Power supplies, we mentioned it. You often see those done redundantly to help with HA. Pathing through the infrastructure. Don't just have one path for traffic to take to get to HQ, have multiple paths. Do you know that we set up this incredible Tampa recording studio for me? And I want a big shout out to Brad at IT Pro TV, who keeps driving down there to make sure my remote recording studio is awesome. And one of the things that we did there was we put in multiple paths to HQ. I've got a fiber optic connection to get back to HQ, and I've got old school DSL as an emergency alternate path through a different provider. This is going to help make sure that IT Pro TV South is always reachable. Switch aggregation. We've seen this evolve over the years. Ronnie, it used to be that you would have to stack the switches on top of each other and connect them via a special cable and special ports, and you made them act like one device. Oh my gosh.
Switch stack.
This has gone really futuristic. We've now got end of rack devices, and they're going to deal with top of rack devices down the row of devices in the data center. So now the two devices are like one, but they're not even geographically next to each other. So there's all kinds of virtualization technologies that aggregate the components together.
All right, now, Anthony, on this next one here, storm control. I remember seeing something like this in switches, but is that what we're talking about?
Yeah, we are actually talking about the storm control capabilities that almost any Cisco device can do now. And techniques like that, I just pulled storm control up as an example of one of many built-in protections against a device going bye-bye because of something like just, a device on the network that is sending out way too much broadcast traffic. If we have a device on the network, if this was 1999 and Ronnie and I were teaching this class, we didn't have techniques like this, and your network could be brought down by some malfunctioning device. Now there are built-in protections against things like broadcast storm, thanks to some freaking out network interface card. And we have built-in protections like storm control and all the different devices that will just naturally take care of this, not be brought down by this problem. And as a result, the network has higher availability.
All right, so let's talk about some of the other different proven methods that we can talk about. So I normally think of things like the first hop redundancy protocols. Can that help address?
You better believe it. So one of the ways you can study this is you can actually use the layers of the OSI model as you study this. So you could go, all right, the physical layer. What are things we could do at the physical layer to improve HA? Obviously, 2 links are better than 1.
Right.
3 links are better than 2. 4 links are better than 3. So we can add redundancy that way at the physical layer. Then the next layer up, we have spanning tree protocol, which stinks. Rapid spanning tree protocol is better. Multiple spanning tree protocol, even better. Or how about no spanning tree whatsoever? Let's get the spanning tree out of the network. Sorry, Radia Perlman. Although, I shouldn't apologize to her. She helped invent a replacement technology called Trill, and Cisco took Trill and made it Fabric Path. So this is eliminating spanning tree protocol altogether. This helps us with HA at layer 2. At layer 3, I think like Ronnie does. First hop reachability protocols, which are like first hop redundancy protocols. I've been saying that wrong all show. So first hop redundancy protocols are like HSRP, VRRP, GLBP. We'll be covering those in this show together. That's great high availability techniques at layer 3. Back to layer 1, we have switches and firewalls and stuff where we can put 2 supervisor engines in, 2 brains of the operation installed right in the chassis. And if one of the brains fails, there's stateful switchover to the other brain, and the device never stops doing its job. So your end users out there never know there was this major catastrophic failure in the device because there was 2 brains and it just switched right over. In fact, there's a really funny term in Cisco networking in the UCS area where if you have a failure and the switchover doesn't work right, you get what's called a split brain condition. And that sounds something like really bad, right? And it is, because you don't have things synced properly when there's been a failure.
Now, let's talk about this acronym for a moment. NSF is non-stop forwarding.
That's right.
And the one that actually confused me when I first saw it on this slide right before the show, SSO, I was talking about single sign-on, but this is supervisor switchover?
Yes, this is stateful switchover.
Stateful
And
switchover.
stateful means that, let's take a firewall example. That's a great example. So think about a firewall. You have this like VPN connection through the firewall that's going on, and then you lose your brain. And so it cuts over to the new brain, and it gives that new brain all of the state information about the connection. So nothing has to be rebuilt. So there's this total nonstop forwarding, not the dropping of a single packet. And something else that we look at with HA, Ronnie, all the time is convergence time. Like, okay, if there's a failure, how long does it take us to be back reliable again? And a lot of times with technologies like nonstop forwarding with stateful switchover, it's just instantaneous.
Yeah. So in the design, since we're talking about that in this particular section, let's just kind of take a few moments to actually think about it from the CCIE perspective as well. So Anthony, if we were to approach this as we're also preparing, let's say, for the CCNP lab, even though we know this helps qualify us to do it, is there anything that's in particular in this section that you go, hey, we definitely need to focus in?
Yeah, not really. I mean, what I want our learners to do at this point is just really understand these concepts from a high level.
Okay.
When there are things that you are going to need to configure, Ronnie and I are going to show you just how to do that. So don't stress about configuration right now. The other thing that I want to emphasize here too, if you're watching this show and you could care less about the exam, that's cool.
Yeah.
Welcome. Yeah, we are. Our goal is not to just have the exam covered. That's just like one of the many things that we're going to do together, Ronnie and I. But what I want to emphasize to you is this: in a production, real-world environment, of course you want high availability. And of course you want it at every possible layer, and you want everything to be highly available. What stops you? Your budget. So that's money, the only realistic. Yeah. At some point you're going to have to be like, all right, we got to cut down on the HA because we're running out of money. So this is almost always in production, the old cost versus benefit analysis that you must do.
Yeah, and I can see this going to the macro level now that we think about it, not only on these individual devices for a single network, but we can even have complete redundancy in data centers, right?
That's right.
Where it's just the complete network is actually redundant.
That's right. The cloud is something that has really brought that to the forefront. You can have this huge virtualized data center in your cloud provider in North America, and you could choose to duplicate that entire thing and drop it into Ireland. Too bad Zach's not here for his Irish accent. So you drop that into Ireland, and great. Now you have this redundant copy halfway around the world. It's just cost. That's really the big thing. Can you afford to do that?
All right, Anthony. Well, thank you again for helping us understand these particular topics as well. So go over the nature and the ideas here of high availability, what's actually involved in it. And as Anthony said, A high-level overview, understanding these design components are going to be key as we also prepare for that exam. And if you aren't, or if you are just taking a look at it, just to actually understand, hopefully we've given you a good review of that as well. So signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show. That there are multiple ways you can deploy wireless LAN environments? Well, find out next right here on IT Pro TV.
You're watching IT Pro TV.
Hello, that's right. We are jumping right into designing WLAN deployments, and here to help us to understand why we need to do so as well as what they are, Anthony Sequeira. Anthony, as we get started here, okay, we might be thinking, Anthony, I've set up a wireless, at my home. Big deal. I just put another wireless access point up and we are ready to go. Why do we care about deployments here?
Yeah, great question, Ronnie. We are not talking about home environments today.
Okay.
Well, I suppose we could be, actually. Right. But the emphasis, remember, with Encore is on the enterprise. So what are we going to do? What options do we have to really do this at scale? So we are going to talk about all kinds of options that could include a smaller environment. So what I've prepared for us here is, first of all, we need to look at what are the primary concerns when we're thinking about the wireless LAN. And I do want to say, too, that this is not the only episode that we're going to do on wireless LANs in Encore. This is just one to kind of kick us off from a design perspective. And when we are thinking about how we're going to implement the wireless LAN, there's two primary concerns that we are going to have. In fact, I'm going to add a third. The first one would be, before we even get to the two that I have on screen for us, the first one really would be, are we going to be deploying a wireless LAN controller or not?
Okay.
We'll see that one of our models is a controllerless deployment.
Right.
So are we going to be using a wireless LAN controller or not? If we are going to be using a wireless LAN controller, I'm going to show you some great deployment models of how you could get that wireless LAN controller placed. And then the other thing that we need to think about is, and it very much hinges on that first point on the slide of the location of the wireless LAN controller, we need to think about the access point to the wireless LAN controller connectivity.
Right.
Because that's the big thing. When we start using the WLC, we need to make sure it has good, solid access to those access points that it's going to control.
All right, so let's jump right in and start talking about this question. So, Anthony, in what type of business environment would I actually say, hey, I need a wireless LAN controller?
Yeah, great question. So immediately when we start to scale and we have like different buildings that are part of our campus infrastructure and things of that nature, right when we get up to large numbers of users, what we call clients, and large numbers of devices, of access points. Mm-hmm. So the clients are those devices. It could be a user, but remember, it could be just some gadget that needs to get Wi-Fi access. As that number of clients increases and as the number of access points increase, you are really being pushed, if not shoved, into the wireless LAN controller arena so that you can more effectively manage all of those clients and those APs, those devices.
So according to what we've already seen here, you said that the placement of these things is actually a key. Why is that so important?
That is going to be a key. One of the reasons it's so important is, remember, we need to make sure that the access points can phone home, if you will, to that wireless LAN controller. So the placement of the WLC is going to be important. Also, your access to the wireless LAN controller as an administrator and latency issues. We'll see some examples of that here. So the placement becomes really important for those kind of reasons.
So how is this going to design when you talk about the placement of these? Is there a particular model that we need to address?
So I'm going to give everybody some simple to understand models here. And they're so straightforward. I probably won't make many flashcards in this area.
Right.
You know, I'm making the flashcards as have time. I'll do more today up on cram.com for our students. There won't be a lot here because watch how simple this is. The first model that we're going to discuss, Ronnie, is the distributed wireless LAN controller deployment. Distributed. We're going to take wireless LAN controllers and we're going to distribute them around our infrastructure as opposed to centralizing them. What are we doing? We're moving them closer to the access points that they control. And that's great because that makes it easier for the APs to communicate with the WLC. We need to make sure, of course, that we can get that access that we need to the wireless LAN controller to reconfigure things. But an often used paradigm here with the distributed deployment is that we take a wireless LAN controller and there's at least one per building. If we have this big campus with lots of different buildings, we're going to have these wireless LAN controllers connecting to distribution layer switches typically, and that's going to get them connectivity back to like the main campus where our IT staff is operating out of, and that ensures that they can get the access they need to the wireless LAN controllers. Now, I've got that great acronym here on screen as a reminder for everyone of how typically we are having the APs communicate with the wireless LAN controller, and it's CAPWAP. So we have those CAPWAP tunnels that are going to be established between the APs and the wireless LAN controllers. And when you use this distributed model, notice a huge benefit we're getting is the CAPWAP tunnels,
right,
they remain in that geographic location. They remain in that building because remember, those are the communication tunnels from the APs to their wireless LAN controller, and we really kind of segment those into the buildings where those WLCs are distributed to. Now, there is something to say you're running that, remember, we are really leaving budget out of this, right? It's like, oh yeah, we have the budget for this really high-end wireless LAN controller in that building, in that building, in that building, in that building. So we're assuming the budget is in place to do that type of an approach.
So with this distributed model, though, as well, are the buildings able to essentially be also managing like between each other, or do they are just independent?
Yeah, the buildings do have that kind of independence, and that's nice. But remember, we got to make sure that all of those wireless LAN controllers do connect to the distribution network, typically a distribution switch, so that we can easily get to all of them from our management of the WLCs.
So another way that we can actually do it then, if we said, look, it's not so much important that each building needs its own wireless LAN controller, but that we need one maybe centralized?
Yeah, so we might go with a centralized model. And by the way, I thought I drew it. I did draw the distributed one. Yeah, after, a few bullet points to discuss it. There's my incredible, I was really proud of this last night.
Very nice.
Yeah. I sent it to my wife for Valentine's Day. She wasn't really impressed for some reason. But so here you can see those green pizza boxes.
Yeah.
Those are the wireless LAN controllers. And by the way, it is important for us to recognize the official Cisco icons and note that when you look close, that might look like an AP, but there is a key distinction on those wireless LAN controllers. If you look at the top of the pizza box, you'll see the arrows, and those arrows on the top of that pizza box, those indicate that it's the wireless LAN controller. And Ronnie, there's our classic example where we're distributing those across different buildings. But to your point, there is a centralized model. So here we have multiple wireless LAN controllers, and certainly this might be just one, but to kind of keep in this same paradigm of the 3 buildings that make up our headquarters, notice we're taking those 3 wireless LAN controllers this time and we are centralizing them. This has a huge advantage as far as our management of the WLCs, right? We could make sure they're in a physically secured, data center location. We can take advantage of all of the data center stuff, our great access. The wireless LAN controllers may be like in the next, server closet over from where I'm sitting. So we have this great ability to manage them. The big thing that we got to watch out for here and make sure we accommodate for is, where are the CapWAP tunnels now? Well, they're going from the buildings where those APs are distributed back to the centralized wireless LAN controllers. It's doable. It's not necessarily a problem. We just have to make sure that we are accommodating that tunneled communication back to the centralized brains of the operation.
So when would we choose instead something like the controllerless type?
Yeah, let's talk about that, because that is one of our big topics here. We, as we said, don't have to use wireless LAN controllers to take advantage of Cisco wireless networking, wireless LANs. Remember the language here. And this, I remember long ago when this technology was invented, I really struggled with these terms. So I don't want our students to have my struggles. There are two types of access points. There are autonomous access points and there's lightweight.
Right.
Now, what messed me up was when you think about those two terms, autonomous sounds way better
than
lightweight.
Right.
Don't think of it in human terms. Like, I want to be autonomous and I don't want to be a lightweight.
Right.
I don't want to go to the gym and be a lightweight,
right,
or being in an adult beverage drinking contest and be a lightweight. That'd be bad. So lightweight kind of had this negative connotation to me, and autonomous had a positive one. Well, reverse it. When you're talking about scalability, you want lightweight. Lightweight means the AP, sorry AP to insult you, but it's dumb. Mm-hmm. It needs a wireless LAN controller for the control plane intelligence to get the job done. So an autonomous access point is got the intelligence built in, so it's superior in that way, but it doesn't function with a wireless LAN controller. Mm-hmm. So it is not as scalable, as sophisticated a solution. So that makes, Ronnie's like, why did you ever struggle with that? That's easy, Anthony. But for whatever reason, the lightweight sounded bad to me, when actually the lightweight is the scalable way to go. Have the wireless LAN controller provide the brains. So here we can see a controllerless environment. And notice I put in parentheses autonomous. So those APs, they possess the intelligence that they need to have their control and data planes all built in them. And we don't have a wireless LAN controller in this non-lightweight environment. And if you look close at those APs that I had fun putting in the buildings, those are APs. They're not wireless LAN controllers.
Now, when we start talking about the centralized idea and the distributed idea, I know that the exam objectives also call out the idea of a cloud-based idea. So when we talk about cloud-based, what's the advantage of it? We kind of realize it's centralized, but what's the advantage of going to cloud-based?
This is really cool. So look at this. We are taking a virtualized wireless LAN controller and we're putting it in the cloud. Now, I always tend, and beat me up for this, I always tend, because I'm such an AWS and Google Cloud Platform nerd, I always tend to give those examples. So, all right, one of the advantages, Ronnie, is that we can put a wireless LAN controller virtualized into AWS, and we're going to save money because it's lower cost than buying the hardware. And Amazon Web Services is going to make sure that's always available for us. It's always going to be up. And this is so great. Just caution me, because remember, this could be private cloud.
Right.
So you could be doing this in your enterprise's private cloud. You don't have to do public cloud. And sometimes we get in that trap of public cloud, public cloud, public cloud. But This could all be controlled by us. But back to the AWS example, because I can't resist, and that's so much more common. So that is a wireless LAN controller that we get in the AWS marketplace, for example, and it is a virtualized WLC. It's there in the cloud. We have the APs in the buildings that are going to be managed by that cloud-based wireless LAN controller. And our big deal is to make sure we have VPN connections properly set up from those buildings to AWS so that that cloud-based WLC can do its CAPWAP with those devices and all that fun stuff.
Now, let's kind of go back now that we have a choice between either centralized or distributed. If I have a branch office somewhere, it doesn't seem like I can do any type of centralized environment, can I?
You could with like an always on WAN circuit and all that stuff, but it's not all that common, to your point. What is often done is something I show here. This is the Flex Connect remote branch design.
Oh, okay.
Yeah. And what you're doing is, to your point, Ronnie, you have the wireless LAN controller at headquarters. You have this WAN link, and then you have your APs out at the remote branch, and Flex Connect is tuned. It's designed for this, and they do all this cool stuff behind the scenes to allow you some really decent scalability over. Look at the example I gave. So this is out of the Cisco official documentation. This is what we could do. We have a 640K WAN circuit. That's darn slow by many of our WAN circuit standards today. But even with this slow circuit, notice that we would have a round trip sustainable latency of 300 milliseconds. So what that's saying is this solution would work even if you have that kind of round trip latency.
Nice.
That's pretty high. Yeah. And you could scale this to 50 APs out in the branch and 1,000 total clients. So for a very small WAN circuit, we end up with some pretty good scalability numbers thanks to that Flex Connect remote branch setup. The last thing, Ronnie, that we wanted to talk about was, and I'm going to give some more information on this in the show notes. So I'll shoot that over to Ronnie right when we're done. I wasn't going to do that, but it's a good idea. I'll send you in the show notes just what you would want if you need more information on this. But just remember that the Cisco solutions can do location services for you. So if you have like RFID chips on stuff that you want to track, these wireless LAN controller solutions from Cisco can do location services. It can use up to 4 channels in the 2.4 gigahertz band. And what you do is you have the RFID chip typically saying it's pre-programmed to be, okay, I'm going to be on channel 6. And then you go up to the wireless LAN controller and you say, okay, scan on channel 6 for those RFIDs and let us know where they are. It does a cool RSSI like measurement thing to plot where that thing is you're tracking.
That's pretty cool.
On a map. It's really cool. And then this is one of the main reasons I'm going to give you some show notes. There's the sophisticated probe request forwarding and some fancy stuff you can do with the Cisco client extensions to make the accuracy of that information even higher. And I'll give you all the details on that if it's something you need to take advantage of.
All right, Anthony. Well, thank you again for helping us to understand more about the idea of WLAN deployments here. We've actually talked about centralized as well as distributed controllerless versus controller-based as well. Cloud, you name it. We've covered several different options for us to make sure that we're familiar with the design options that we have available to us. But there is more CCNP Encore to come, but that is later for another show. So signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro.
Deployment or cloud deployment, which one should we choose, or should we actually choose both? Find out next right here on IT Pro TV.
You're watching IT Pro TV.
That's right. It is a match for this particular decade. Do we choose on-prem deployment or in the cloud deployment? And here, of course, to referee us is going to be Anthony Sakara. Anthony, why should we choose, or why do we care?
Yeah, I know. Isn't it interesting that all of a sudden, relatively all of a sudden, we now have this other design decision, and that is, are we going to be putting stuff in the traditional on-prem environment, on-prem standing for on-premises? And someone once pointed out to me that on-prem sounds like a very small fruit, an exotic fruit, doesn't it? An on-prem? Anyways.
Sure. Why not?
Whatever,
yeah,
dude.
Whatever.
So think about this. Like, there are times when Ronnie and I were just looking at this. We were looking at some of the new wireless LAN controllers that Cisco offers, and you come across some of them and they'll end in C, their model number, and that is because they are fine-tuned to work in the cloud. There are a couple of different reasons you may want to turn to the cloud for your deployment of Cisco technology. Reason number one, you are mainly a cloud-based infrastructure. So if you're putting all your infrastructure these days into the cloud and you want to add like firepower security services from Cisco, next generation firewalls and intrusion prevention systems, you want a cloud-based copy because all your stuff is up there in the cloud. So that's the number one reason you might want to do this. But another really interesting, powerful reason you might want to do this is more and more we are interacting with the internet and cloud-based resources on a daily basis. So we may have already a high bandwidth VPN up to the cloud. Why not have some services located up there so we can take advantage of like the high availability, Ronnie, and the automated backups and all of the great cloud stuff. By parking the service up there, we can take advantage of everything that the cloud brings.
Now, Anthony, again, working with routers and switches, I kind of think maybe as a Cisco guy, I might be losing some of my contact with that. So I think that the on-prem is the way to go because I have full control of everything that I need right here. What do you think?
That is really true. And remember this, if you spend enough money with your cloud provider, you could have the level of control that you want. So don't forget that. Like, if you gave them enough money, you would be able to physically go visit that device. And that's pretty funny to think about. But I'm being dead serious. Like, we know by default, when we deploy to the cloud, we are doing a multi-tenancy environment by default. So let's say you have a virtual firewall that you purchased from Cisco and you put it up in AWS. By default, it's on a machine with other customers' stuff, but pay them enough and you can get your own machine.
Right.
Pay them enough and you'll get a specific machine, and they'll even send you the serial number so that you can, just know where your machine is and the ID on your machine, and it's like your hardware in the cloud. Again, you'll be paying more for that privilege. Let's do this. Let's see how easy it would be to deploy some of these new Cisco resources to the cloud. So what I've done is I've gone into a little free tier AWS account that I have access to, Ronnie, and I'm going to go into the EC2. This is their virtual machine service, if you will. And I'm going to go into my running instances, and I don't have any because this is, again, a little free tier account. Oh, I actually do have one. It's an Ansible host, and it's not running. Poor sad little thing. And it's going to get even more sad for this host. I'm going to go and terminate it right now. That's right. When you terminate, you delete. Gone. Yep. So anyways, I'm going to launch an instance. And the instance that I'm going to launch is going to be from the AWS Marketplace. And look at all of these different things that are featured in here. So all of these, what used to be physical appliances, are now being implemented as cloud-based virtual appliances. And this is so exciting for us because we can spin them up and practice with them. If I do a search on Cisco, we have 36 different products. This list is growing all the time of devices that we can spin up in the cloud. Here's an adaptive security virtual appliance, an ASAV standard package. If you select this, you see that if you were to spin it up on an M4 large instance, which looks like to me is the lowest tier that you could use of hardware, it's going to cost you 69 cents an hour for the software from Cisco, and it's going to cost you 10 cents an hour for a total of 79 cents an hour for this ASAV. Not too expensive at all, especially if you're going to be turning this device on and off during maybe downtimes as you're experimenting, or if you're in a practice lab, you would just be practicing with it and then immediately turning it off. So notice we are going to be able to deploy these devices right out of the marketplace into our cloud infrastructure. And Ronnie, when we get into the more sophisticated devices, like here's the Cisco Firepower Management Center. So here is the management center to manage our next generation firewalls. What's going to be critical, notice there's no cost for the software, but what's going to be critical here is that you follow the documentation to deploy it properly. And they will link to that in here. For instance, here is the usage guidelines. And if I click on this, it's going to bring me into the documentation. And right here, it's going to say, deploy the Firepower Management Center virtual on the AWS cloud. That would be the link right there that I would be interested in. And it is going to walk us through how to get this properly implemented into AWS. They will walk you through each step that you have to do in AWS. But understand, if you were really going to do this, I'd want you to come to IT Pro TV, and I'd want you to take at least our cloud practitioner entry-level AWS training, because it scares me to think that you're just following the directions of the AWS setup you need to do and not having a clue about what you're doing there. Because what happens is if you have to troubleshoot it, you're not going to have much luck because you don't know what any of that AWS stuff is that you had to manipulate. So please consider, if you're going to be doing cloud-based deployments a lot of the time, consider the very basic levels of training on that cloud.
Yeah, there's no doubt that there are benefits, of course, to having some of your own equipment, but this is the ease of deployment in the cloud, I think, after following those directions, since they have such nice documentation, is probably one of the biggest benefits that we can actually have, instead of just getting a piece of equipment like a Cisco ASA and saying, well, here you go, have fun figuring it out.
A lot of times too, Ronnie, one point I wanted to make is that, when we want to practice, a lot of times this is a great way to practice because Cisco will give you a 90-day eval for the virtual software. So think about that. It's like they just shipped you this really expensive piece of equipment and said, enjoy it for 90 days and ship it back. That's basically what's happening here. So it's a very exciting way to get practice with their latest generation of technologies up in the cloud.
All right. Well, thank you for at least helping us to understand that there are decisions that may need to be made during design, and here understanding that whether your environment has to do with as much money as you can actually throw at it, you can get everything that you want, or if you're actually using something like AWS, make sure you read the documentation as well. But the on-prem, pretty much the standard way that we think about doing things, right? We deploy the device, we add power to it, we cable it up, and we, of course, begin to configure it. But all that depends on what you actually need. Well, this is a great place for us to end in terms of this episode. So signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore Show. Wide area networks, specifically SD-WAN. Well, what does that mean? Find out next right here on IT Pro TV.
You're watching IT Pro TV.
We are jumping in and taking a look at SD-WAN, and here to help us to understand this concept a bit better is going to be Anthony Sequeira. Anthony, as we get started here, did we just tack on just two letters, SD, to WAN, and we don't really need to know anything else?
Yeah, software defined? Okay, cool. So
Yeah. What does that mean?
yeah, what exactly does that mean in terms of the wide area network? And, Ronnie, there's a theme that we've run into already in these episodes. We're going to run into it again today. We're going to run into it later this afternoon when we turn our attention to SD access. It's this recurring theme of underlay and overlay.
Okay.
It almost seems like that could be kind of the motto of Encore. So let's take a look. Let's jump right in. And I wanted to start with, just a reminder. There is actually two variations of this that you could run into with Cisco systems. So there's a Meraki, depending on who you're talking to, SD-WAN solution. And then there's what's called Cisco SD-WAN. And then notice in parentheses, I have Viptela. So this is a solution that came from the 2017 acquisition by Cisco Systems of Viptela. It's very much their solution, still alive and well. We'll even see that Cisco is sticking with their names for things. This reminds me of SourceFire's acquisition with the firepower stuff. So we'll see where they're sticking with a lot of their naming conventions, a lot of the technologies pretty much the way it was with Viptela, but we'll see that they're making some moves with it. But anyways, I just wanted to quickly remind you, don't be confused if you see this Meraki SD-WAN. The thing about that one that's interesting is it really focuses on the unified threat management of Cisco systems. So your devices are intelligently updating themselves with the latest in security vulnerabilities and patches and all that stuff. We've get a little bit of that, and we'll see more and more of that coming to the Viptela solution. So I could see these all coming under one umbrella eventually.
All right, so let's talk about this briefly and kind of lay the groundwork. All right, we know what the WAN solutions have been. MPLS, we've done regular links in between them as far as privately leased lines. All these different things. Why switch to SD-WAN?
Yeah. Thank you, Ronnie. And that is what I wanted to spend the most time on in this episode. So I put together a list consulting several different sources. Like, what is that WAN wish list that we might have, right? Like, we're in a traditional WAN. What's our ultimate wish list? Well, lowering costs. Okay, so all the time we want cheaper WAN costs, of course. Increase the automation and orchestration. So when we bring up a new WAN link to some new destination, we would want that as automated as possible. Also, the automation of just fundamental maintenance type tasks and all of that. Automation, we know, we're wanting it all the time now across all of our things. But look at the third point. This one is interesting. That is a more seamless integration with all this public cloud. Or even private cloud, but this was really like public cloud in mind. Think about it, We're doing more and more all the time, Ronnie, with AWS, with Google Cloud, with Azure, with maybe IBM's cloud. So we want our WAN solution to be as cognizant of that as possible and to be able to seamlessly work with it. A great illustration on this that I saw that was just talking about, like, look at your main connection to HQ. A lot of organizations now are doing a ton of cloud stuff from like a branch office, and they're sending all of that traffic destined to, let's say, AWS to the corporate headquarters, and then it goes from there to AWS. It's like, why not just send it directly to AWS? You're putting this tremendous strain on the main WAN link when the traffic is destined for the cloud anyways.
Yeah, it seems like a waste of bandwidth, right? The very fact that it's actually coming to you and then you're sending it back out that WAN link.
Absolutely. We used to have driving reasons where we wanted to send everything from the branches to HQ, maybe security stuff and things like that, but those reasons don't typically exist anymore. We've got security services out at the branch now. Let's have a better integration with cloud. Another thing that a lot of WAN people want to do is they want to make sure that all this software as a service, Google Docs and Office 365 and all these SaaS apps, they want to make sure that they are running well in the WAN. So that's another wish. Transport independence. This is a big one. We might have some satellite links. We might have some layer 3 MPLS VPNs. In some parts of the world, there's still a bunch of frame relay.
Right.
So we could have all of this cellular, all of these different underlay technologies. There it is again, that word, underlay technologies. We could have all this hodgepodge of stuff, and we would love for a solution to lay right on top of that. Obviously, that's what we're going to have. SD-WAN, as you know, addresses all of these wishes. Enhance app visibility. So when we have an application that is running from the branch office to headquarters and then to another branch, we want visibility into that application. And finally, end-to-end segmentation. That would be nice. So we might have our research and dev team, and we want them dynamically segmented as they transit the WAN. All of these desires are made possible by the SD-WAN solution from Cisco, and it's a bunch of moving parts that make it happen. But before we talk about those parts, I just want to emphasize something here that I attempted to draw out for you. By the way, this is like my best PowerPoint work of all time.
Okay.
Ronnie, see how nice that cloud looks?
It looks beautiful.
Ronnie was like, dude, your cloud's like way off, hanging off the edge of your slide. I'm like, oh, that's by design. Anyways, so look at this, folks. Any mix of WAN tech, do you see that there? So, Ronnie, there's our underlay.
Right.
It's like, it doesn't matter. Yeah, you could have a home office worker with their cable modem or DSL if they're in an old DSL scenario. That's fine. Any underlying WAN technology for the underlay, and then notice, what is SD-WAN? This is the best definition of it I've ever heard. It's simply a cloud-delivered overlay for wide area networking. That's it. So we are going to be providing this overlay intelligence from the cloud as the way we're going to implement the overlay in this case.
Now, after listening to how you actually went through that list of different kind of wishes that we wanted, so just check me if I'm actually right in my assumption here. So what we're actually saying is this overlay kind of makes that stuff as transparent and tries to help reach those goals as much as possible, so that maybe the administrators that's not great at the underlaying technology, they can focus in on the functionality that they really want to accomplish?
Exactly.
Okay.
Exactly. So we mentioned that, someone's going to be sitting there controlling all this. Ronnie, what is that specifically? Well, if you look at the classic Viptela solution, it's a graphical user interface, Ronnie, called vManage. Mm-hmm. So the little lowercase v in front of all these roles tells us that it's Viptela, okay. Yeah. So vManage is the classic GUI from Viptela that Cisco now owns and you can use. But notice what I have on screen. Where do you think all this technology is going as far as management goes?
DNA.
Sure, Cisco's DNA center. So as I record this for you, as Ronnie and I are speaking to you, that's all arriving. In fact, it already has in Cisco DNA Center. So you can do all of this no longer using that GUI from Viptela, the vManage GUI, but it's still totally supported. And I imagine there's plenty of shops out there that are like, yeah, we're not going to do this in DNA Center yet. We're already doing it fine in vManage. So vManage is your graphical user interface, Ronnie, for managing the SD-WAN. What is the brains behind it? What's the control plane intelligence for these wide area network circuits? It's vSmart controllers. Now, what is a vSmart controller? Like, is it a special appliance? No, it's actually a virtual machine. Remember, this is cloud-based technology, so you're going to have a virtual machine set up or multiple of them set up, and those are your vSmart controllers. Now, where are your routers? There's got to be routers here. Well, they're your vBond and your vEdge devices. The vBond is a router in this scenario with a very special purpose. It's authenticating everyone, and it's like taking care of pathing decisions. So it is a key, unique role that exists for our routers. The rest of our routers are vEdge devices, we call them. So it's a integrated service router, or it's a cloud service router, and it is one that is running this Viptela software to give it the vEdge device intelligence. So lots of options on your routers. That's great news. Both hardware routers, Ronnie, we can use, or complete software solutions.
All right, so let's talk about some of these different devices at these levels that you're talking about that you see right here.
Yeah.
So you had actually mentioned this idea of the control plane. So lead us through not only that control plane again, but the data plane devices that we need to be
Absolutely. And that's a key for your Encore exam objectives. And I love how Ronnie's always keeping us conscious of those exam objectives for those of us that are interested. So yeah, vManage, your single pane of glass, that's really your network management plane, right? And then the vSmart controller, that's your control plane intelligence. Notice it's DTLS tunnels that are going to be dynamically formed from your vSmart controller out to those vEdge routers. And there's a new protocol called the Overlay Management Protocol, which handles the establishment and the maintenance of the neighborships in this relationship. Notice the vEdge routers, they're the data plane. They're moving all this traffic through the WAN for us, and iOS XE is the main operating system that we find here.
All right, so tell us just a brief idea. How different is this iOS XE versus just a regular
You have
iOS?
to really hunt to see that, oh, I'm on an XE device. Yeah,
Okay.
so they do a great job of a consistent look and feel. And if you want to practice with this, I know it's not officially part of Encore, but if you want to get some iOS XE practice on a device that would really be used in this solution, head up to the Amazon Web Service Marketplace.
Right.
There is the CSR 1000V. Have you seen that up there?
I have.
Yeah, it's like a 30 or 60 day eval license for you. So you can spin that up. You can practice away at the iOS XE command line, and you could set up the components of the SD-WAN if there's an evaluation license for that. I'm almost positive there is. And so you could be evaluating it that way. By the way, another way to play with some of this tech is the sandbox up at Cisco's DevNet. So there's an SD-WAN sandbox. You've got your vSmart controllers, you've got your vEdge devices, you've got a vBond router. It's all right there ready to play with.
You know, the neat thing that I found out about the XE that I really didn't know until I started looking at it is that ability to actually do some of that network programming, programmability that we need into it. Whereas somebody might go, well, it's an iOS, it's an iOS. Well, no, the way that we interact with the iOS is through the command line. On this one, you have both that ability to do so, something we're familiar with, but also the ability to start using that SD portion of it, the network programmability portion. And that's what makes a difference here.
I think it's clear, Ronnie, how we're going to see every single OS soon from Cisco supporting the programmability.
Right.
But I love what you said there. iOS XE was one of the first to offer that. Very cool. So one of the things that I struggled with, Ronnie, and I really elaborated here on it for our students, was the vBond.
Right.
You know, it's like, okay, the vSmart controller, yeah, that's just a software-defined controller doing the control plane. Okay, that makes sense. And then your vEdge devices. But this vBond was interesting. Its full name, as you can see here, is the vBond Orchestrator. And like I said, one of the key aspects of this device is that it's going to be authenticating those vSmart controllers and those vEdge devices. And the other interesting thing about this is you could set all this up, and you wouldn't have but one public IP address. So that's pretty interesting. This is the one device that would require a public IP out of all of the devices that we've spoken of. So this is a router. Remember now, this isn't a VM. This is a router that has the special job. I got to back up. What I just said there was technically incorrect. This is a router. It might be implemented as a VM if you have a virtual router doing this, but it is the router software was my point. It's not like this is just a VM that doesn't have the router intelligence built in. So this orchestrator is hugely important, a required component.
Hey, welcome back to the channel, everybody. This is Kevin, and in this week's video we want to talk about this term that you may have heard, software defined. We have software defined networking, software defined WAN, software defined access. What's up with all these software defined technologies? What do they do for us? And what pieces and parts make up a Cisco solution? That's what we're going to talk about in this week's video. And as always, if you enjoy this content, please do me a huge favor and click the like button down below and subscribe so you don't miss any of our weekly content. Now let's begin our software defined journey by taking a look first at software defined networking, or SDN. And I want us to consider some traditional networking devices like routers and switches. They have three different planes of operation. They have the data plane, which is concerned with getting a frame or a packet in one interface and out of the egress interface as quickly as possible. The control plane, that's where our algorithms run. For example, a router's going to run OSPF at this plane. The switch might run spanning tree protocol at this plane. These are the planes that populate the tables that will be used to forward data by the data plane. And when we as administrators go to configure a router or switch, we're interfacing with the management plane. Perhaps we secure shell into a switch to do some configuration. We're coming in on the management plane. Now let's take a look at software-defined networking and see how this can radically shift our perspective of how we manage our devices day to day. The model that we just described is known as a distributed control plane, meaning that the control planes of these devices are distributed in the devices. In other words, each device has its own control plane. However, with an SDN controller, or a software-defined networking controller, what we can do in some cases is take those control planes on those individual devices and have them run inside of the SDN controller. So that appliance is in charge of running all of those algorithms, and the configuration and any update information is going to be pushed down from the SDN controller down to those devices. And that communication is using something called an API. That's an application programming interface. And we typically say that the API going from the controller down to the device is a southbound interface. Consider a compass. South is usually down, and when we draw out an SDN network, we typically draw the devices being managed below the SDN controller. So we're going down to those devices, and these APIs are therefore called southbound interfaces, or SBI for short. And now that we've got our control plane centralized in that SDN controller, we've now migrated from a distributed control plane to a centralized control plane. Now, when I say we have an API running between the controller and the device, what's an example of that? Well, there's an industry standard called OpenFlow. Cisco has their own proprietary version called OpFlex, but those are a couple of examples of southbound interfaces. And the advantage that we as administrators get from this is we can do what is called intent-based networking. We can express our intent, such as I want to treat video traffic this way, and I want to treat voice traffic this way, and I want to give this application this level of security and this level of quality of service. And the way we express our intent is not by going to each device and entering correct commands on each device. We express our intent through an application, and this application is going to talk to the controller using an NBI, a northbound interface, because the applications, we draw that above the SDN controller or north of the controller. So these are going to be called NBIs, northbound interfaces. And here we're not talking about OpFlex or OpenFlow. We're using something called REST APIs. And REST stands for Representational State Transfer. What does that mean exactly? It means we're using HTTP verbs, like you would use when interacting with a web page, to send information to the controller, our intent, and to retrieve information from the controller. So we can see, for example, the status of a router. And this information being sent using these HTTP verbs needs to be formatted in a certain way. And one of the popular formats is JSON. JSON, that stands for JavaScript Object Notation. And this is a fairly generic look at how SDN works, but let's talk Cisco-specific solutions. Sometimes a Cisco SDN controller is not going to use a centralized control plane. It very well may leave the control planes in the devices. It just kind of depends on how things are set up. So it's not always going to be a centralized control plane. But when we say SDN controller, what are we talking about in the Cisco world? Well, it varies. Are we talking about the data center, or are we talking about the enterprise network? In the data center, I'd like you to know that the SDN controller of choice is the Cisco APIC. That's the Application Policy Infrastructure Controller. That's part of Cisco's ACI, or application-centric infrastructure, that they have for data centers. But in the enterprise, instead of using a Cisco APIC, which is going to be talking typically to Nexus devices, we're going to use Cisco DNA Center, where DNA stands for Digital Network Architecture. This allows us to do that intent-based networking that I was talking about. And as a few examples of what Cisco DNA Center can do, we can use it to design our network, we can draw topologies, we can pre-configure our devices such that they can be plugged in and they'll automatically download their configuration. In other words, we can pre-provision them. We can do our day-to-day configuration using Cisco DNA Center. It's great for troubleshooting and monitoring what's going on. And when we talk about troubleshooting, this is not just a typical help interface. The troubleshooting is going to be proactive. It's going to watch for things, and it's going to tell you about things that it noticed, and it's going to give you recommended remediation steps. And this troubleshooting intelligence comes from Cisco TAC engineers who have seen these issues as part of their job. So this is like a knowledge base of Cisco TAC built into Cisco DNA Center. And you also hear that Cisco DNA Center gives you platform support. What we mean by platform support is we can write applications to talk to Cisco DNA Center. Now, Cisco DNA Center, it has a beautiful GUI interface we can go in and use, and we can do a lot from that interface. But we don't have to do everything or anything from that interface. We can do everything programmatically. We can write applications, maybe using Python, maybe modify somebody else's application for our environment, and we can run that application, and it's going to send instructions to the APIs known to Cisco DNA Center to do any of these functions. And that's an overview of SDN, software-defined networking. Our next technology is software-defined WAN, or software-defined wide area networks. But before we jump into that SD-WAN discussion, I want to tell you about a way to taste test for free some of our courses. Here's a challenge that many students have. They're not sure which track they want to go down. Is it security? Is it enterprise? One of my favorites is collaboration. Well, here you can taste test some of these different topics. Specifically, you can check out the first module in any of these courses. You might want to start at CCNA, or if you've already got your CCNA, you can taste test the core content for enterprise, security, collaboration. If you've already completed your core training in security or enterprise, you can take the next step. Take a NARCI for enterprise, or SNCF for security, or if you don't want to stay Cisco specific, you may want to check out our newest course, which is Professional Ethical Hacking. That gets you ready for version 11 of the Certified Ethical Hacker exam, which, by the way, is currently listed as the 5th most in-demand certification to have, above any Cisco certification because of the incredible demand for cybersecurity professionals. Or you may want to check out the new version of CompTIA's Network Plus certification if you're just getting into networking. But again, you can sign up to go through the first module in any or all of these courses for free. Just go to kwtrain.com/course-samples. Again, that's kwtrain.com/course-samples, and taste test any or all of these training courses. Now, let's take a look at SD-WAN, which stands for Software-Defined Wide Area Network. And to understand the benefits of SD-WAN, let's first consider a traditional WAN. In a traditional LAN, we had our remote sites that connected to our central site. Maybe there was a data center at that central site, and we could use a variety of WAN technologies to do that. Here is a couple of examples. We have MPLS, or Metro Ethernet. And because we were going over a single circuit from one site to another site, we had very predictable performance. We could configure security on those endpoint routers. A disadvantage, though, is if we wanted to go out to the internet, we might be forced to go through that HQ location, or perhaps we had to do backhauling. Maybe we had to go to the data center to have a security check done, and then we could come back to our remote site and then go out over our internet connection. That's not terribly efficient. With software-defined wide area networking, we make the observation that a lot of applications are migrating to the cloud. We've got Amazon's cloud, AWS, Amazon Web Services, Microsoft Azure, we've got Google Cloud, Microsoft Office is available in the cloud, Dropbox, and on and on and on. And the thing is, these applications that are cloud-based, they can give us security and quality of service and a predictable performance experience. We don't need to do any backhauling back to the headquarters. If we have a remote site and it wants to go out to the internet, it can go straight out to the internet. And the thing I want you to understand here is that we might have a variety of technologies that are interconnecting all of our sites. Here I've got just 3 sites, but things could get much more complicated in larger enterprises. For example, consider this topology with a few different locations, and you see how these devices are physically interconnected. This is what we call the underlay network, or we might refer to this as the physical infrastructure. This is how our devices are physically interconnected. But with SD-WAN, we can define our topology. In other words, we can define our wide area network connections. Perhaps I want a connection from the upper left office to the lower right office, and a connection from the lower left office to that upper right data center. And I'm not sure what the performance is going to be because I'm not sure which path I'm going to take. Well, what we can do with SD-WAN is put a virtual topology on top of that physical topology. This is called our SD-WAN overlay network. This is our virtual infrastructure where logically, from the perspective of these routers, it looks like they have a connection from their site to the next hop, which is the other site. Now, in reality, they may be going through multiple other routers in between, but it doesn't look like that to them because what's happening here is we have virtual secured tunnels that are set up through the WAN. And we're not going from router to router and configuring things individually. That's one of the big advantages. Those control plane functions we were talking about, they no longer have to reside in the routers. They can be done inside of our SD-WAN controller. And we can have a wide variety of physical WAN connections, everything from cellular to Metro Ethernet or cable modem or MPLS, and the list goes on and on. And as long as we educate our SD-WAN controller about those technologies, it will take care of it. It will send out appropriate configuration commands to our routers. It knows what's available on those routers, and it's going to give us that security and quality of service and predictable performance that we had with those traditional point-to-point WAN connections. And again, let's talk Cisco-specific solutions. Cisco acquired a company called Viptela back in 2017. It's this Viptela technology that Cisco is using for their SD-WAN solution. And we can break down the functions and components in Cisco's SD-WAN solution into a few different layers of operation. Let's consider those layers. We've got the data plane, the control plane, and the management and orchestration planes. They're so similar, we'll just group them together. Let's talk about some of the pieces and parts that live at these different planes of operation. First is vManage up at the management and orchestration plane. This is our interface to do the configuration. In fact, I'll take you out live to a vManage interface in a few moments and you'll see what it looks like, and I'll give you a link where you can go explore on your own. Another SD-WAN component living at this layer is vBond. And the job of vBond is to understand how the network is physically constructed and to figure out how all of these different interconnected components can work together. And vBond also lets us do something called zero-touch provisioning. In other words, we can completely provision or pre-configure a device before it ever arrives at one of our sites. Let's say a new router is shipped to one of our remote sites. Somebody plugs it in, and it's going to phone home, basically. It's going to go up to a Cisco site, provide its serial number, be given a certificate, and it's going to be told the IP address for vManage and a control plane device we'll talk about in a moment called vSmart. In fact, let's go ahead and talk about that device, vSmart, down at the control plane. vSmart, as we see here, does policy enforcement. So after we create a policy, vSmart is in charge of enforcing that policy and sending those policies out to other SD-WAN devices. And route information from remote sites that's received using a protocol called OMP. the overlay management protocol, because we're dealing with an overlay network. And here we are doing that centralized control plane that we talked about earlier. And if you're a Star Trek fan, you might relate this to the Borg, where they have one mind, the collective they call it. That's kind of what's going on here. The control plane is a lot like the Borg collective. It is the mind, if you will, for all of the different components making up our SD-WAN. And finally, down at the data plane, we have the edge routers themselves. And these are responsible for doing the forwarding of our traffic. And these edge routers, they could be physical routers or they could be virtual routers. And now that we've seen these pieces and parts, let's take a look at how this might be implemented in the real world. Here we see a sample topology with a main campus location. We've got a couple of branch locations. We've got a physical data center. We've got a cloud data center. And they're all connected using a variety of WAN technologies. But remember, SD-WAN is an overlay technology. So the underlying physical infrastructure, that is transparent to the traffic flowing over our overlay network. And at each of these locations, we have a Cisco vEdge router. And these routers are going to securely talk to one another over dynamically formed IPsec tunnels. And this is going to make up our data plane that we talked about a moment ago. And also remember the control elements that we discussed, where we had Cisco's vManage, vBond, vSmart. We would form a connection between each of these control elements and each of these edge routers. We're going to use those control elements for the provisioning and configuration of those edge devices. And also I mentioned that these routers could be physical or they could be virtual. Well, Cisco's vEdge routers are physical routers, and they're running Viptela's operating system. We could also use some models of ISR, or integrated services routers, or ASRs, aggregation service routers. And the software, or the virtual routers, include Cisco's Cloud Services Router, the CSR1000V, or a vEdge Cloud Router, again running Viptela's operating system. And that's a look at how Cisco provides an SD-WAN solution based on their Viptela acquisition. But I promised to go out and show you vManage. Let's take a look at that now. Here we're sitting at a vManage interface, and Cisco makes this available to us for free to go explore. It's part of their dCloud service. Now, this is read-only. We're not going to be able to go in and reconfigure anything. But if you just want to go in and explore, you can go to cisco.com/go/SD-WAN demos. Then you'll select Live Demo, and you'll be given instructions as to how to log into this vManage console. Looks like we've got a couple of vSmart devices. We've got 8 WAN edge routers. We've got a couple of vBond devices. We've got one instance of vManage, which we're on now. And we can go in and check out some of the different tools, monitoring options that we have available. And that's an overview of Cisco's SD-WAN solution. Next up, let's consider SD Access. And we could, at this high level, loosely consider SD Access as an advancement or a replacement for traditional access control lists. Let's take a look at some of its features. Cisco tells us that SD Access is the next generation in policy enforcement. Instead of having individual access control lists that say this IP address can go to this other IP address using this TCP port number, here we're going to use security group ACLs. So here, rather than identifying someone based on the IP address they're using at the moment, it's based on their identity. And their identity is going to be defined on a device called Cisco ISE, the Identity Services Engine. And like our other software-defined technologies, we're going to be virtualizing the physical network. In fact, we could have multiple virtual networks all using the same physical network, and we could give different virtual networks different policies, even though they're sharing the same physical network. That would be much more of a challenge to do with traditional ACLs. In fact, let's consider a basic example of using a traditional ACL where we are manually configuring access control. For example, let's say that we have an access control list that says we want to permit PC1, which has an IP address of 192.168.1.100. We want to permit that IP address to go to the server, which has an IP address of 192.0.2.3. We want it to go to that server using a TCP port 443, the secure HTTP port. And with that ACL in place on router R1, that traffic is going to be allowed, no problem. But what if that user takes their PC, or maybe it's a laptop, they take it somewhere else in the building or in the enterprise? They're suddenly connected to a different subnet, and they've got a different IP address. Here, the IP address is 203.0.113.125. There's no ACL that says that's going to be permitted, and they're going to be denied access to the server when that user should have access to the server. Can you see with today's more mobile workforce, it's going to be harder and harder to limit or grant access to resources based on ACLs? Instead, enter SD access. With a software-defined access, we're going to have security groups. And let's pretend we have a security group called IT, and it has a couple of members, Kevin and Charles. And the identity of each member, that's going to be defined on a device called Cisco ISE, the Identity Services Engine. And here, instead of having a regular ACL that says permit this IP address to go to the HTTPS port on the server, here we have a security group ACL, which says permit the IT security group to go to that server on that port. So here I've logged in to PC1 with my identity of Kevin, and that's a member of the IT group, and that is permitted to get to the server. And if I move my device to another location, I'm still Kevin. I can still connect with my identity. So regardless of where I am in the network, I still have permission to get to the server. Now let's take a look at some of the pieces and parts making up a Cisco SD Access solution. And again, we'll break this into different layers, beginning down at the bottom, the physical layer. And the physical layer is made up of our actual infrastructure devices. Here we might have things like routers and switches, wireless LAN controllers. Up at the network layer, we have both the physical underlay network and the virtualized network that lies on top of the underlay network, the SD Access overlay network. This is sometimes referred to as our virtual fabric. If we move up to the controller layer, we see Cisco DNA Center, which is going to be sending instructions using those southbound APIs out to our devices. That's going to live at the controller layer, as well as Cisco ISE, that's granting permission for different identities. And our interface to manage all of this is going to be done through the GUI of Cisco DNA Center. That's up at the management layer. And after going through this video, I hope you have a better sense for what these SD technologies are all about. SDN, SD-WAN, SD Access. And as we wrap up, I just want to remind you again about the opportunity you have to taste test
An understanding of what SD-WAN's about. What about SD Access? Find out next right here on IT Pro TV.
You're watching IT Pro TV.
SD-WAN, SD Access. What in the world is that about? Well, we're about to find out with Anthony Sequeira. So, Anthony, as we get started here and we start to actually realize that we're starting to see more and more of these terms beginning with SD, we just talked about SD-WAN. SD Access, that sounds kind of silly. What are we really talking about here?
Yeah, well, once again, we're talking about that high level of programmability, automation, even full-blown orchestration to the access layer of the enterprise network. Remember, Ronnie, when we say access layer, we're talking about getting all of our users onto the enterprise environment. What's broken about that? Well, I don't know. It seems like a lot of times we're not all that well equipped for like mobile,
Right.
you know? So what if we have a user that's going to be like, hey, look, I need to work instead of in the production area, I need to work all next week out of marketing. Could they take all of their stuff and relocate it? And could our network dynamically evolve regarding that? Or would we have a bunch of manual processes? The answer is, in most networks, it's a manual process. We have to go in and redo VLAN assignments and do all this stuff manually. So this is an area that really begs for automation. Now, once again, Ronnie, one of the things that our students should really concentrate here on is that separation of the control plane, the data plane. So let's look at the SD Access architecture, and I don't want our students to panic. When you first look at this, you're like, oh my gosh, all that is going on? Well, yeah, but it's really not that much. Let's start down at the bottom. So we've got our routers, we've got our switches, we've got our wireless access points and potentially wireless LAN controllers. There's two ingredients here that we might not be all that accustomed to, and that's the Cisco's DNA Center. That's that incredible single pane of glass for management, Ronnie. And then we've got the ICE. No, not the cocktail party variation of ICE. It's the Identity Service Engine.
Right.
So that is the replacement technology for the old Cisco ACS. that, was like ubiquitous. The access control server was everywhere. Now we're trying to see the ICE be the device that's everywhere. The ICE, by the way, can be a physical appliance or it can be implemented as a virtual machine. So there's all the stuff that makes up the physical layer. Now, look, there's already a concept here we're familiar with, underlay and overlay. Just like we had with SD-WAN, we have an underlay network layer here. That would be like your routing protocol, or if you're in a layer 2 only environment and you want to do rapid spanning tree protocol, that's the technology there in the underlay. And then notice there's the overlay layer, and that is Lisp, which we're going to talk about in detail with you, because that is, at first, a tricky one to get your head around.
Right.
There's VXLAN, which there's more to that than meets the eye, and then CTS. So we'll talk about those in separate episodes, but that's the dynamic, like new, exciting technology that makes up the overlay, Ronnie. And then at the controller layer, it's just the intelligence of the DNA center and the ICE that we added to our network down at the physical layer. And then one step up from that, they're just showing us here what they call the management layer, and that's DNA center again. So you can see there really isn't all that much new in a design like this to make this programmable, automated, orchestrated access layer. Notice that the automation, design, policy, provision, assurance, those are just major divisions that we have inside of DNA Center that would allow you to drill into those different areas. So for example, Ronnie, if you said to me, Anthony, we've got 3 new cat switches that we want provisioned inside our access layer. I went ahead and racked them and stacked them. They're ready to go. Now I would go into the provision area inside DNA Center. I would see those devices and I would go ahead and give them the policy that provisions them on the network. So we just drill into the different areas as needed.
So as I'm looking at this diagram, in the controller layer there, you have both Cisco DNA Center and ICE. Do they have to be together?
Great question, great question. First of all, technically, the ICE would be optional, although to get every possible functionality out of SD Access, you would want ICE for sure right next to DNA Center. And yeah, those are definitely separate entities, Ronnie, and they are really, really, really doing different things. The DNA Center is in charge of all of that automation and provisioning, some security, but the ICE's job is everything involving security.
Now, what looks like the big change here, at least from what I can tell, because when I take a look at your diagram, it seems like it's almost trying to match up like OSI model style things when you kind of break it down.
Yes. We love to think that way.
Yeah, but in the network layer where you have this divided up, where you actually have both the overlay and the underlayer in that network layer there, it looks like that there's different technologies than what I was expecting, like IP and MAC addresses and stuff like that. So why the big change there? What's going on here?
Well, I think the big thing is there is this real emphasis on overlay technologies. And you want to realize that just like we had in the SD-WAN, what's so cool about it, Ronnie, is the underlay, it just doesn't matter as long as it works.
Right.
You know, so that's really the big point of that separation. And I can't believe I haven't mentioned this yet. In fact, Ronnie, I haven't even mentioned this to you back at our desks. There was this big panic with software-defined networking that we were all going to be out of jobs. Well, this is proof that that's not correct because someone has to be responsible for that underlay, right?
Right.
That's traditional networking, and that still has to go on. There is, as we'll discuss in a minute, an automated underlay that you can roll out with this, but companies aren't going to move to that right away. Of course not. They're going to build the underlay with the traditional skills and technologies that they know. And then they will put the overlay on top and start doing this SD access. So there's job security in here.
All right, so the underlay here on the details that we need to try and understand as we start taking a look at this. ISIS? Really?
I couldn't wait for you to see this slide.
I haven't seen it actually in production in forever.
ISIS is making a huge comeback.
Okay.
It's remarkable. There's a technology, I was telling you about this, Ronnie, in the data center. And in the data center now, we tend not to run any spanning tree protocol. Instead, we run something called Fabric Path.
Right.
And Fabric Path is essentially MAC address routing. And the routing intelligence is ISIS.
Okay.
But you don't interact with ISIS at all. You don't see it.
Okay.
It's built into Fabric Path. It just runs itself, right?
Okay.
But now it's official. ISIS is making a comeback because, yes, this is the recommended IGP of the underlay. They want you to go in and configure ISIS. Could you use another IGP? Sure you could. But their recommendation is ISIS. So notice you would not be doing any spanning tree.
Yeah, that's kind of amazing. Now, you had talked about using automation, but here you have manual or automated. So if we're doing automated, why would we choose a manual perhaps?
For many organizations, it's because they wouldn't trust
Okay.
full, complete automation of their access layer from scratch, right? They're just like, no. Well, let's get comfortable with this first. So for a lot of companies, they just make sure that their underlay is working great, and then they'll go and start automating with their overlay. But it is, please, worth noting, and these are the kinds of things that might come up on an exam. Technically, you could take all of the gear, Ronnie, for your access layer. You could click a few buttons in DNA Center and provision it all from the ground up. That means the underlay would be automated and then the overlay on top of that.
All right, so if we do this manually, do I have to learn how to configure ISIS?
ISIS, you sure do. If you're going to follow their recommendations.
Wow.
Yep. And that's why you're seeing it come back in all of the blueprints. ISIS is making a resurgence. I'm teaching, what am I teaching? NSLED. So the 420 class.
The design.
Yes.
Right.
And I promise no jokes on 420. But yeah, so that's the design one, Ronnie. And it's really funny. Like one of the very early modules is I have to take students through designing ISIS. Yeah. Well, I haven't taught that in like 15 years. I'm not kidding. Or longer. So very funny that it's making a comeback. So the overlay, that's where we just have some, I mean, you talk cutting edge.
Yeah.
This is it. These are the new cutting edge technologies, folks. At the control plane, we have that Lisp. It's actually a modified version of Lisp to work better with SD access. There's the VXLAN. We're going to elaborate on those for you in episodes coming up. And then something else we're going to elaborate on them for, it's TrustSec. That's right. The identity service engine there is your TrustSec workhorse. And that's a great reason to bring it into the fold. Now, TrustSec, just give you a heads up on that. It's super, super simple. So don't get all freaked out that, oh my gosh, I'm going to have to relearn how to secure a network. No, it's security based around tag values, and you're going to love what a straightforward, relatively simple idea that is. By the way, don't forget now, on the VXLAN piece and the Lisp piece, Ronnie and I are going to do separate episodes for you on those. Just so you know, let me just not completely gloss over those now. The idea behind Lisp is an easier way to quickly track the end users and their devices in our infrastructure. We're going to actually circumvent the routing table, and we're going to very quickly locate those entities with Lisp. It's really cool. And then the VXLAN piece, that's going to give us a super hyper scalable way to do VLANs. Yeah, we can have 16 million of the things, and you'll see where we are going to take advantage of VXLAN to eliminate a ton of disadvantages about the traditional VLAN and then like spanning tree approach. So you're going to really love those technologies, and we'll elaborate on them for you. Now, when we look inside the fabric Ronnie, of the SD Access solution, you're going to notice like there's a virtual network that we create out of these components. There's a host pool that identifies the participants. There's a scalable group. There's an Anycast gateway. All of these are necessary components so that the overall SD Access works as planned. And all of this you're going to be setting up through that single pane of glass in the Cisco DNA Center. The Anycast gateway is a cool feature in and of itself. That's going to enable you, Ronnie, to have one IP address as a default gateway across all of the different areas of your access cloud. So it's like kind of mind-boggling. It's like taking a default gateway and magically making it available everywhere.
Wow.
So it's some very cool technology. So that's the major aspects of the SD Access solution. And I know it looks like an intimidating volume of stuff, but just like anything else, I just highly recommend you break it all down. So in this episode, just understand that overall architecture that makes up SD Access, and then build upon that in our episodes to come. Like, you'll know all about VXLAN. You'll know all about Lisp and those different new technologies that make it a reality.
All right, Anthony, thank you again for helping us here with SD Access. Remember that there's a key feature that we've already heard about in SD-WAN as well as SD Access, which is that separation between overlay and underlay. Those seem to actually be a theme that you're going to carry through with anything that actually deals with some type of software-defined networking as well. Now, when we start talking about that too, Anthony also helped us to review some of those different technologies as well as understand what this is about. Now, when I first thought about it, I always thought that it was more about identity management than anything else.
Sure.
But Anthony actually helped us to understand that this is about getting access to, well, those access layer devices that we think about. So all that's good review for us, and make sure that we actually go ahead and take the time maybe to watch it again if we need to. But this is a great place for us to go ahead and sign off then. For IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.
That's right, you've been hearing it in your head. Jitter, delay, latency. Well, you know QoS is coming up. Find out more right here on IT Pro TV.
You're watching IT Pro TV.
We are jumping into QoS, quality of service. And if the terms jitter, delay, and latency have been scaring you, you don't have to fear any longer. Anthony Sequeira is here to help us. Anthony, here we are. We are jumping into this topic, and most of us that have come from the CCNA level, we might have learned the terminology so that we could get through the exam. But then we said, I'll never have to see that again.
Yeah.
And Anthony is back again.
Yeah,
So
we're going to take a deep dive.
All right.
We are, and we're really going to make sure that we get this.
Great.
Okay. I love that your CCNA students are here, Ronnie. They know the basics. Let's go a little deeper than that. And by the way, at the start of this episode, I thought you were poking fun at me when you said jitter, because I've had like
6
3
monsters.
and let's see, a very large coffee from one of the local coffee houses. Okay, first things first, I really always love to start here when we talk about quality of service. And that's what Ronnie was alluding to, and that is the evils that exist in the network that are ready to make people really upset. Most especially those people that are on voice over IP phone calls or that are watching videos. You know, we see in our network when we're watching our ridiculously high quality videos over the network, what do you see? You see some skipping, you
Right.
see some jumping. And I always hear the production staff that we have, which are incredible here, they always say stuff like, hey, by the way, that's just our network. So in our defense, well, we probably don't have QoS set up here properly on the wireless. And that's where we're seeing
Right.
challenges. And we'll discuss that. In, if not this episode, we have a part 2 on QoS coming up. But here's the deal. This is an extremely important topic, not just for the voice over IP or the video crowd. This will impact a lot of what we're trying to do in enterprises. And let's face it, we're always starving for bandwidth these days, it seems. Gone are the days where it's like, oh my gosh, what are we going to do with this 50 meg WAN link we have at home? You know, now that's like nothing. I have 300 over 300 at my office in Tampa, Florida, you know, and that's not enough for what I'm trying to do. I'm shooting IT Pro TV episodes that are 3 gigs in size that I got to move around. So bandwidth's on short supply. We have delay called latency. Ronnie brought up the great one. This is the ultimate evil. Well, there's 2 that are the ultimate evils. Variation in latency, that's called jitter, and packet loss. Those are a nightmare for a lot of different forms of traffic, Ronnie. The variation in delay, the jitter, you see, early on they figured out there's things like propagation delay and serialization delay and processing delay. Those are different delays that are very predictable.
Right.
Okay? And so they figured out like, oh, no problem, we'll take care of this. We'll have a buffer. It reminds me of the old extended skip protection for those of you that are older like me that we had like on the Walkmans and the Discmans. And you could run and that CD wouldn't skip because it was actually playing you the music out of a buffer. So that's how they did the skip protection. Well, quality of service started like that. But notice that doesn't help you with huge variations in delay. If you are running like at 80 milliseconds round trip time, then all of a sudden you're 800 milliseconds, then you're back to 80, then you're at 300. Those variations, that's a real problem from a quality of service perspective. So we have all those potential nightmares. What are we going to do for a solution? Well, there's 3 overall approaches. And I love the first one. Don't do anything.
Yeah. Best effort.
Yeah, best effort. And that's actually not true. You do something. If that's your approach to QoS, oh, you're doing something. You're getting out the wallet and you are making massive expenditures on capacity.
Right.
Like my America wallet.
I like it. Love it.
This is non-leather. I was a vegan for 3 days, and that's how I ended up with this wallet. So I had to get rid of the leather one.
Of course.
Yeah. So you're buying a ton of bandwidth, Ronnie.
Right.
That's your approach.
Right.
You're good because you're not doing any quality of service configuration. You have to make sure there's way more bandwidth than you need. And that's just not practical in a lot of scenarios. So for most of us who can't afford to overindulge in bandwidth, we're going to do an integrated services approach or a differentiated services approach. The world has gone diff-serve. Integrated services does still have applications, but it is not nearly as widely used. Just so you know, the integrated services approach is really all about one protocol, the RSVP protocol. And this is where you're going to have signaling information sent forward in the path of the traffic that you want to give QoS to, and you do reservations for that traffic.
Okay.
And I can see from your expression, Ronnie, you're like, oh, that seems like a lot of work.
Yes.
That's exactly the issue with it. There's so much overhead and so much that goes into that process. Wouldn't it be smarter just to treat stuff with a special QoS treatment hop by hop?
Right.
And that's what we have with the differentiated services approach. The differentiated services approach begins by classifying traffic. We classify traffic first. We like to classify traffic as close to the edge of the network as possible. Let me even give you a better definition. We like to do it as close to the source as possible. So if Ronnie is sitting at his desk and he picks up his voice over IP phone to make a phone call, we want to classify it right there right at the source of the traffic, if at all possible. And what could we use to classify it? Well, there's a whole bunch of different things you could use to classify your traffic. You could use QoS groups, which are internal to routers. You could use just an interface. Ronnie could say, you know what? All my stuff's important. Everything coming out of my workstation and voice over IP phone, it's all critical. So he could ask that his interfaces be the classification for his important traffic. You could do it by MAC address. Or you could have traffic that already has quality of service markings. This is the beauty of the differentiated services approach. Let's say we partner with some organization and they're like, hey, we have high priority transactional traffic that we need to send into you. We've marked it as high priority. Great. All we need to do is honor what's called trust their QoS markings, and then they will get the treatment that we want inside our organization. So the first step is classification. The second step is marking.
So when you talk about this idea of classifying as close to the source as possible, does that mean that all QoS implementations are going to be acceptable? In other words, does it matter in terms of brand or vendor? Do they implement them differently or anything?
No, that is an excellent question. The great news, Ronnie, is these are now standardized.
Okay.
So yeah, we've got the differentiated services code point that we can use to classify and also mark traffic. We've got the experimental bits inside of MPLS. Silly name, because now they're used for QoS. But when they were invented, they had no idea what they were going to do with them. Isn't that funny? There's IP precedents. I'll talk to you more about these. But these methods of classifying, and then we're, again, going to mark traffic, yes, they are based on standards. And Ronnie, great example is voice over IP traffic.
Right.
We now all agree across the whole wide world that we're going to mark that as expedited forwarding, a specific marking that that traffic gets, and everybody knows that the EF traffic is voice, and they're all treating it with care, and that's why voice over IP is a hit, one of the reasons. There's one on this list I wanted to point out to you, Ronnie. I haven't asked you about this, so this is, live reaction here. NBAR, have you played with NBAR yet?
I have not. I was going to ask you about that as well, because source destination IP look fairly kind of logical. TCP, UDP, logical. NBAR, not so logical.
What is NBAR?
And then what is NBAR 2?
I know. Hilarious. So I'm old school, and NBAR 2 caught me by surprise. That's must be relatively recent. That's network-based application recognition.
Oh.
I'm close.
Right.
It's a little protocol analyzer that's built into your Cisco routers and switches. Yeah, so it's a little protocol analyzer, and you can tell NBAR like, oh, okay, what types of traffic are running, and you see, okay, web traffic, FTP traffic, gaming traffic, voice over IP traffic. It will show you a snapshot of what's running for traffic on your network, and you could take that NBAR information and then classify based on it. So pretty cool that you have a little built-in traffic analyzer. NBAR 2 seeks to do it more optimally with the devices. So one of the things that we got to do clearly for this to work is we have to classify our traffic. What's the voice traffic? Are we going to prioritize that? Of course we are. What's scavenger traffic? What's traffic that we want to like take a back seat? If your company allows gaming, if your company allows Facebook usage while at work, those might be forms of traffic that you want deprioritized. What you want to do is mark the traffic so that based on those markings, each hop along the path can give the quality of service treatment that that form of traffic warrants. And look at this on screen here. The great news is we can mark at the, we've got basically physical or internal with QoS groups. So 1 through 3, including MPLS layer 2.5, we like to joke, right?
Right.
So we have QoS groups, We have class of service at layer 2. We have the MPLS experimental bits at layer 2.5, and then we have IP precedence or DSCP at layer 3. What this means is it doesn't matter what layer you're working at the OSI, Ronnie, you have the ability to mark traffic to signify what classification it has.
All right, so let me ask this question now that you have this up here. Why would I choose, let's say, layer 3 versus layer 2?
Great question. So we would always want to DSCP mark. So the differentiated service code point is the latest, greatest way to mark traffic. It's what you always want to do.
Okay.
The only time you wouldn't do that is when you can't.
Okay.
And that is when it's a layer 2 switch,
All right.
right? The layer 2 switch is like, I don't understand layer 3. All I know is layer 2.
Okay.
So I don't know why I'm doing a robot. The layer 2 switch is not a robot, is it, Ronnie? But what you would do is, for that little device, you'd be like, okay, little fella, mark what you can, and that's the COS. And then what you do, Ronnie, is that traffic goes to a router, right?
Right.
You can then have the router go, oh, I see you did COS. Thanks, little switch. And then it can have a mapping table.
Okay.
You set up a mapping
Right.
table on it, and it will map the COS to the DSCP and send it on its way.
So there's no conflict there if you mark
Nope.
something at layer 2 and then it goes to layer 3 and a different marking or a different thing happens.
Right.
Okay.
We have mapping tables
Right.
that we use to
Awesome.
do that translation. Yep. And now remember, you always have choice over whether you're going to honor the markings, what we call trust the markings that you're receiving. But in most well-designed networks, that's exactly what we do. I mentioned the IP phone, by the way. IP phone, Cisco was thinking this through. When you pick up the IP phone and you make a phone call, by default, that traffic is being marked with DSCP expedited forwarding. So
Right.
you have the markings taking place in an automated fashion. Very, very smart. So classification, marking, right? Simple stuff. Before we leave this concept, I did want to elaborate with you on some of those markings because we didn't go into detail on this. So the one that confuses everybody is the type of service section of an IPv4 packet. So there's this toss byte, we call it. Those 8 bits that make up the toss byte, in the early days of IP, they said, oh, I know what to do. Let's take the first 3 bits, leftmost bits, 765, those bits, and they will be for IP precedence. And this was perfectly in keeping with the 3 class of service bits used at layer 2 for for QoS markings. Great. But it didn't take long for the engineers to go, boy, we sure are wasting bits.
Mm-hmm.
Wouldn't it be great to give meaning to those other bits in that field? And that's what DSCP gives us. So the new and improved methodology that we've used for a long time now, actually it's not that new anymore, is the differentiated services code point approach. Notice it's going to use the 4 bits, so bits, wait a minute, let me make sure I get this exactly right. So you've got 4 bits to give the DSCP value, and then you have 2 bits utilized for explicit congestion notification, and then there's 1 bit that has another purpose that I didn't bother to list here. The bottom line is all the bits of the toss byte finally have meaning, Ronnie, and finally can communicate excellent information. So the DSCP marking gives us the quality of service treatment we want to do with much more flexibility than just the IP precedence approach. But notice there's explicit congestion notification. So now devices have a way to communicate, I'm super congested, just slow down, at the rate of which you're sending me information potentially. We call those the flow control bits.
Now, is there some overlap with that explicit congestion? Because it looks like it's 9 bits altogether.
Yeah, and I've confused myself on how I presented this. The DSCP bits incorporate the IP precedence bits because yeah, we can't have, we don't have 9 bits here. So this is great. We have a part 2.
Right.
I'm going to elaborate on how these bits work out. But here's the great news I have for everybody as you look at this presentation. You might think, wait a minute, is it DSCP or is it IP precedence? And are those two compatible? Yes, they are. So there's this nice compatibility where if you have an older system that's marking using the IP precedence 3 bits only, the way they set this up, that plugs right into the DSCP marking system, okay? So Ronnie, don't let me forget to elaborate on how those bits line up. I do believe it's the first 4 are DSCP, and then we have 2 bits for a job I can't think of, and then the 2 explicit congestion notification bits, but we'll pull it up and we'll elaborate on it. The last thing we wanted to talk about in this episode is Ronnie mentioned standardization. Oh boy, is that happening more than ever. The differentiated service code point approach allows us to define kind of standard per hop behaviors. Remember what I said earlier in this episode. Voice always gets expedited forwarding. It gets this incredible priority. So notice there's a PHB, a per hop behavior that we dedicate to something like voice. There's the assured forwarding where we can say, okay, you're not going to get as much priority as voice, but you're going to fall in the higher priority stuff. There's the default forwarding behavior for like all unmarked traffic. There's a class selector per hop behavior. What's this all about? This is basically honoring letter for letter the IP precedence and class of service approach. It's like, okay, we're not going to do any fancy DSCP type stuff. We will just honor the 3-bit approach. So there's these per hop behaviors that help standardize this. Now, Ronnie, I want to wrap up this episode by saying this to you. While a lot of this technology is standards based, remember how you classify traffic might be very unique.
Right.
For instance, I said gaming or Facebook, we're going to scavenger class those. Wait a minute. What if you work at a gaming company? Well, the gaming traffic is your most important thing. So I want to emphasize that how you classify traffic, that of course is up to you. But please give voice traffic expedited forwarding. As we'll talk about in the next episode, if voice doesn't get big time priority, it's not a good experience.
All right, Anthony, thank you for helping us this far. I know that you said that we have a part 2 coming up to actually kind of dive into it a little bit deeper. But in this episode, we did review the idea that we're really taking a look at differentiated services is what we're actually focusing in on instead of the other ones that we were talking about, as well as taking a look at the per hop behavior as well. Those are actually key elements that you want to make sure that you understand as we continue to move forward. And of course, the idea of latency and jitter and delay, all those are actually possibilities on definitions that, of course, you should be familiar with too. But there is more to come, so this is a great place for us to sign off. For IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.
About, well, some of the basics in QoS. You mean there has to be a part 2? Yes, there does. Find out more right here on IT Pro TV.
You're watching IT Pro TV.
We are taking a look at describing QoS Part 2, The Revenge of Anthony Sequeira. And so here we go. Anthony Sequeira, we are in a Part 2 on QoS. We've already talked about latency, jitter, delay a little bit, marking a little bit, but we have more?
We do.
Oh,
We do.
Okay, lay it on us, Anthony.
Yeah. Well, the first thing we need to do is we need to pick up on a point of confusion from the last episode. Corolla, if we could, yeah, thank you. Go to my screen here. Look at this. I was all completely thrown off. Ronnie was like, well, how do the bits lay out? And why are you only describing 6 of the 8 bits? Yeah, that's because there is a typo here. This is not 4 bits. This is 6 bits. So if we are using an IP precedence approach to marking, it's using the first 3 high order bits and it's doing nothing with the 5 other bits. No. In a DSCP world, we'll use all the bits. The first 6 are your DSCP bits, and then the next 2 is for explicit congestion notifications. So there's the explanation on that confusion. And we love, as we said, the DSCP approach, Ronnie. Now, I also wanted to give you my analogy, Ronnie, for classification and marking that we talked about last time. We love classification and marking as that initial step of QoS. And my analogy that's perfect for us here in Florida is theme parks.
Right.
What do you love to get at a theme park if you can afford it? The Fast Pass.
Yes.
You
Definitely.
are now classified and marked, and you get a special lane, and you don't have to wait 2 hours for Harry Potter and his wonderful wizarding world. Wizarding?
Wizarding. Yeah.
I think I mispronounced it even. Not my thing, but I did have to take my daughter, and I'm too cheap for a Fast Pass.
Oh,
so we were scavenger traffic, and we waited 3 hours for that 10-minute ride on a broomstick or whatever we were doing. Anyways,
you sound bitter.
I'll deal with my issues later. But so classification and marking, just think about that Fast Pass at the theme park.
Great
That's
analogy.
my favorite analogy on
like
that
it.
one. All right, well, let's jump into the current stuff that we have to cover. And that is going to be a continuation on our discussion. And I wanted to start by reviewing a little bit with you the markings that were so important. And to do that, I wanted to impress upon you how wireless is often configured. In Cisco wireless environments, they have us categorize the traffic in our SSID, in our Wi-Fi network, as platinum, gold, silver, or bronze. Bronze being the kind of scavenger stuff, the stuff that gets background bandwidth. So notice it's AF, Assured Forwarding Class 11 that is used. That gets a numeric value of 10, and yes, that is referring to how the bits are set, by the way. That's pretty cool. Silver class might be best effort, unmarked. Gold class, maybe that's reserved for video, and it gets an assured forwarding of 41. What did we say about voice? It always should be marked expedited forwarding, and sure enough it is. It has a decimal value for 46 at the marking, and it's that expedited forwarding. So notice, inside a wireless QoS environment, even though it's wireless, we're still going to be classifying, marking, and then treating traffic differently based on those markings.
Now, Anthony, I've seen numbers, at least on blogs and different things, where they've described like the expedited forwarding as DSCP 46. Is that the same marking that we're talking about?
That's what they're saying. Yep.
Okay.
There's kind of a lazy way to say expedited forwarding. But yeah, if you wanted to give details, you would say, oh, that's DSCP marking of 46.
Okay.
That's right. By the way, I should have said this up front, Ronnie. You know, QoS, it's one of those topics, and I am not kidding you. Ronnie and I could do easy 60 episodes on QoS. I'm not kidding. It reminds me of BGP. You know, if you really wanted to cover BGP in the scope that it could be done, it could be 60 episodes.
Easily.
You know, so that's one of the, don't let that frustrate you, okay? Just recognize the fact that, oh my gosh, this is a very deep subject, and, you know, just don't let it frustrate you. I've always just kind of embraced the fact that, like, wow, I'll never be an expert in any of these technologies. I'm just gonna like try and learn, you know, as much as I can. I would love to just teach QoS for a living. I love it that much, but unfortunately, can't do that.
All right, so Anthony, now that we understand a bit more about the classifying and marking, especially with your analogy of the fast pass, that's a great analogy to think about.
You're ready to punish some traffic.
Yeah, so let's talk about this idea and these strange terms, okay? So the strange term that we normally hear, of course, is policing and shaping. Is that?
Yeah.
Okay, so
I love these terms because when we think of police, unfortunately, I want you to think police brutality.
Police brutality.
Yeah, unfortunately, I know I'm not making light of that.
Right.
I'm just saying that just think that the police is going to be like, sorry, you're speeding, and they are going to write you a ticket.
Okay.
In QoS terms, it means you're typically going to drop or remark traffic. So you've got someone trying to send too much traffic, maybe it's gaming traffic, and you have said that's low priority traffic, and you've got this WAN link, and they are hammering your WAN link with all this traffic. In a traffic policing environment, the excess traffic is typically dropped. You could remark it. So you could say, oh, I see you're assured forwarding 11. We're going to mark you down so you can, and then the idea there is the next hop will punish the traffic that has that reduced marking. But the most common policing configuration is to drop excess traffic. Shaping, it's kinder and gentler. It doesn't drop traffic. It says, hey, I'll just buffer you so that when the interface is less busy, I'll send you. And that makes sense by the name, right?
Yeah.
It's trying to make a more smooth traffic shape, and it's not as strict as policing. Now, what is going on this slide, Ronnie, where we have single rate 2 color, single rate 3 color, 2 rate 3? These are all different types of policers. And here's what the colors mean. The 2 color versus 3 color. That is, let it pass, which the cop can do. I haven't seen it in a long time, but sometimes they go, hey, kid, drive slow, move on. And they don't give you a ticket.
Right.
It's very rare. The policer can do that inside QoS. So it can pass the traffic, or it can drop the traffic, or it can remark the traffic. That's what we refer to there as colors. Different treatments. And then the 1 rate versus 2 rate, that is whether we allow excess burst.
Okay.
So you could say, look, we'd like things kept to this rate, but we understand that sometimes there's going to be, a lot going on, so we'll allow bursting above that rate. If you permit that, that's what's called a 2 rate policer. Okay, so it's just different words to describe different types of traffic policers that we're going to run into. Now, what most people think of QoS is this slide right here. QoS is an incredibly vast topic. As I told you in this episode, I could do 60 EPs on this, easy. What most people think QoS is this, congestion management. But you already get a sense for it's way more than just this. Now, this has gone through kind of generations, and that's how I listed them. As like, early on, all we did was first in, first out. Yep, first packet in, first packet out. And then they came up with the idea of, let's put packets into different queues and round robin between the queues. And then they came up with, this will be fancy, weighted round robin, where you could take your voice traffic and go, one of those packets goes, one of those packets goes, one of those packets goes, and then I'll go to the other queues. And then another one, another one, another one, and you see what's happening. That's getting more attention than the other queues. But that led to problems. Queue starvation. There's a queue out here that's like starving.
Right.
So they came up with custom queuing, and then priority queuing, and then weighted fare queuing.
That last one.
Yeah.
That next to last one is killing me.
The next to last one?
Yeah,
class-based weighted fare queuing.
Yeah.
And here's the deal. We don't do any of the early methods anymore. The whole world really comes down to class-based weighted fair queuing or low latency queuing. And really, it's as simple. If you were using voice over IP, you do LLQ, because LLQ gives this really strict priority class to the voice and then does class-based weighted fair queuing automatically for everything else, and it works great. If you're not using voice, then you could use class-based weighted fair queuing. But those last two, they're the congestion mechanisms of the future.
So help me out here. With the congestion management, that doesn't take place, even the low latency queuing, unless we do have congestion, correct?
Very good point.
Okay.
If you don't have congestion, well, then it's FIFO, because there's plenty of bandwidth for all, and the packets are just, line speed going out. Great point.
All right, so with the management, we kind of understand what we're trying to do, since you've actually kind of described that. But there's another term that we also need to talk about here, which is the idea of avoidance.
Yeah, CA,
so,
congestion avoidance.
So congestion avoidance, congestion management, it doesn't really sound like much difference. Is there a lot of difference here?
There is.
Okay.
So you said correctly, Ronnie, the congestion management tools only kick in when there's congestion. Congestion avoidance, let's not have congestion at all.
Okay.
Let's avoid having to do the low latency queuing. Let's not have congestion. And there have been two approaches: random early detection, or now what we all use is the better version, weighted random early detection. And you see the Star Trek logo.
Yeah. Yeah, you've got to actually,
all right.
I'm assuming it's an analogy.
John is a big Star Trek fan, right?
He is.
One of our founders.
Deep Space Nine. Deep Space Nine.
Okay.
He loves that one.
All right. I'm a casual Star Trek fan. I remember one of the movies, right?
Right.
And Spock, I actually started crying. It was an effective scene. I cried.
Right.
Spock was in some like radiation chamber, and he was going to stay in there so that he could save the entire ship.
The Wrath of Khan.
Okay. In that movie, he went up to the glass, I remember, and was talking to Kirk, right? And he was like, Captain, it's logical. Like, the good of the many outweigh the good of the one or the few. And I started crying. And then I realized, oh my gosh, that's weighted random early detection. You see, what we do is we sacrifice low priority packets for the good of all the packets. So isn't that amazing? That's how this works.
Yeah.
So one of the Facebook packets comes up. Sorry, Facebook. One of that comes up, and the queue is starting to get congested. So this notices that. We're getting close to congestion. So weighted random early detection takes that Facebook packet and randomly chucks it. So it's getting rid, it's sacrificing low priority packets. And I guess that's where my analogy breaks down a little bit. Spock is far too important. It should have been one of those guys in the red shirts that they always beam down to the planet first that get eaten by the monster. One of those guys should have been in the radiation chamber. But anyways, you get the idea. So what a fascinating concept. Low priority packets getting sacrificed for the good of everyone else. And that's how weighted random early detection works.
All right, now I noticed that as we start to move through our concepts on QoS, I'm seeing an acronym that I don't know if anybody might actually be super familiar with this. LFI, what are we talking about?
Yeah, I was surprised that this was not covered in some of the Encore materials that I saw. It should be. This is a very real thing that's still used today. This is link fragmentation and interleaving, and we often put it in a category of what we call conditioners. You know what would be another line conditioner or QoS conditioner? Compression.
Okay.
That's a valid QoS thing. Oh, don't send that big, text file. Compress it down and send it. Link fragmentation and interleaving is a great technique on real low-speed links. And I guess that's why authors are starting to drop mention of this. They're like, well, everything's high speed now. Not in some of the networks I visit, especially overseas. Like I said, there's frame relays still pumping away in some town in, I don't know, a country other than my own. I bet you there's frame relay running here in the US.
There probably still is.
Sure. All right. Enough of that tangent. Link fragmentation and interleaving. Ronnie, you're going to love this. We got this big packet coming through, and it's about to hit this really slow speed WAN link. The LFI QoS mechanism goes chop, 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 chop. It fragments that big packet, and it interleaves. Link fragmentation and interleaving, it interleaves something like the voice packets, so they don't get stuck behind this huge packet. They get woven into that packet that was intentionally fragmented. So that's LFI. And that's, I think, the last of the QoS features. So let me try and recap this, Ronnie, and correct me if I'm wrong. We have classification.
Right.
We have marking. We have traffic shaping or policing. We have congestion management, congestion avoidance, and then we have potentially conditioners. And there's your full gamut of differentiated services, quality of service topics.
All right, Anthony. Well, thank you for helping us through these 2 episodes here on QoS, and with a big, gigantic description of a bunch of technology to make sure you take advantage of both of these episodes, watch them through a couple of different times, and ensure that you understand the concepts that are actually presented here. But there is, of course, more on-core to cover switching mechanisms and software switching mechanisms. Well, find out next right here on IT Pro TV.
You're watching IT Pro TV.
That's right. We're going to be taking a look at Cisco Express Forwarding today, and here to help us out to understand what that even is going to be Anthony Sequeira. Anthony, let's talk about this idea of Cisco Express Forwarding, and why do we really care? You tell me, at least before the show, that there's kind of a little bit of a history behind this.
Yeah, there sure is. This is part of like the arms race, if you will, in high speed, ways to move traffic. I remember when there was initially the cache-based approach that was invented, and you, I'm sure, taught this long ago, Ronnie, like I did. It was all about, okay, if the device is moving traffic from one port to another for one host to communicate with another host, let's cache that result. So when they go to talk again, that is in a cache, and the traffic can be quickly moved with that cached entry. Then someone wisely came along and said, let's pre-build all of that in the hardware. Remember, we want all this information in a hardware ASIC, an application specific, thank you, integrated circuit. We want all of this information in there because it's way faster than doing anything in software. So let's pre-build it. Let's not wait for demand. Let's put everything that we need to move traffic blazingly fast. Let's put it all in a hardware mechanism. And that's what we're going to look at today, Ronnie. In fact, we can even see these mechanisms at the command line.
So if this may be for a CCNA student coming up, they might have heard about the term CEF, but might not have heard that explanation. But that other method that you were talking about, we sometimes refer to that as process switching. Is that correct?
Yes, that's right. So process switching involving a demand-based approach. And the thing that's interesting is we can't always do this Cisco Express forwarding, this really blazingly fast. There are exceptions to that. And the process switching needs to get involved for certain types of traffic. For instance, what if the traffic is destined for that device itself? Well, then it's going to go ahead and do the older school process switching. But the good news is for almost all of the traffic, the through traffic, then this really blazingly fast Cisco Express forwarding is going to take over. And it's important to realize that a lot of us don't even touch this because Cisco Express forwarding is all set up by default on these Cisco devices.
So what are we actually taking a look at then? So now that you've explained it, what else are we actually going to do with it?
Yeah. Let's see what this looks like at the command line. and let's see some of the manipulations that we might end up making. So Ronnie, here I am on the R1 device that we've used with some BGP in Encore. And that means if I do a show IP route, we've got lots of stuff going on in here. We've certainly got our connected interfaces. We've got our OSPF learned information. We've got our BGP learned information. And what we're looking at right now is actually formally called the RIB. This is the routing information base. Kind of think of this as the software version of this routing information. So in Ceph, it's going to look at this RIB information and it's going to use it to populate the fib. Now, when I was growing up, a fib meant a lie.
Right.
No lies here. We're not lying. The fib is the forwarding information base. So the routing information base is used to construct the forwarding information base. So how do we see that? We know show IP route. We're so accustomed to that. That shows us the RIB. How do we see the fib? Well, that is show IP Ceph, I think. and you don't really ever have to do this. That's why these commands are always tricky for me to remember. And I got lucky. Show IP Ceph does show us the forwarding information base. And you can see, Ronnie, how that's being pre-populated based on that routing information base.
Now, as we go through this, most people may actually be taking a look and going, well, what's the big deal? And it sounds like two different tables. Why is the idea of this fib so important? Is it because the fib actually resides on the ASIC as well?
That's right.
Okay.
So the router is using that fib whenever possible to just be faster. And, you know, this is really great stuff. Now, notice there's directions in here like, okay, if the traffic needs to go to this destination, use this next hop, use this interface. But then you can see things like drop. So it would make drop decisions very, very quickly. Now you might see one in here. You might get lucky when you're looking at the fib and you might see a punt. And when you see the term punt, this doesn't have to do with Super Bowl Sunday or what certain football teams have to do a lot of, punt, unfortunately. But that word, when we're talking about these structures, what it means is it means Ceph can't handle it. Remember we said there are certain cases where Ceph can't be used and we have to go to the old school process switching approach, and that's what it does. It punts it to the older mechanisms, which in all fairness are still fast. It's just not as fast as Cisco Express forwarding.
Yeah, this actually sounds like something that's now all the things are starting to click in place, understanding the use of the ASICs, getting everything else in place here. But there's some other tables that we also need to be aware of, right?
Yeah, that's right. We have the fib, which is based on the routing information base. That's the layer 3 information, but we also need layer 2 information. So how is that handled? Well, think about this. We know we can run, what is it, ARP? I think I'm on a Windows machine right now. So if we do a show ARP, yes, this is the required layer 2 information, Ronnie. So we've got our MAC address to IP address mappings in here. This is additional information that the router's going to need. So this is the ARP cache we're looking at. That would be the process switching mechanism. But what about that lightning fast, Cisco Express forwarding? Well, it uses what's called the adjacency table. So if I do show adjacency detail is our command here, we'll see the lightning fast information that's in the adjacency table, and it's the ARP table that helps populate this information. So yeah. Really, Ronnie, when you talk about Ceph, you're talking about the forwarding information base and the adjacency table working together to give this system all it needs to forward traffic blazingly fast.
Now, before we move on, because you just went through a ton of concepts, let's make sure that we get this right. So the rib helps us to populate the fib.
You got it.
So that actually is that way. And now we're actually saying that the ARP table also helps us to populate the adjacency table as well.
You got it.
So we actually are working on layer 3 and layer 2, which is what we have to do in networking.
That's right. The device needs that MAC address information. It needs that prefix information. So we're providing it in the hardware ASIC with everything it needs. And we're using the old school routing table and the ARP cache to do that.
All right, now I've done this before, Anthony, because people start having questions as they start doing their own study. So, and I've had to kind of gloss over it. I've used the term CAM table before and TCAM, and in CCA when I've taught this, and of course I was like, look, we do need to get to it, but more than likely at the CCNP level, not at the CCNA. So I kind of pushed it off because I know that it can get very detailed. Why don't you help us out there a little bit?
Yeah, we're on a router right now, and we know, we've just covered the primary mechanisms of the software approach and the hardware approach. Great. Now let's move over to a switch. When we move over to a switch, there's something that over there that's really interesting to talk about. And by the way, notice that those commands were tough for me to remember on the router because we don't really have to use them much. There are these corner cases where Ceph is freaking out and causing a problem, but I've got to admit, I've never seen it in production. I've never seen it in a practice lab. It is so rare that you would mess with this stuff. Now, when we come over to the switch, we're going to see that there is an opportunity for a little bit of configuration here, and I'm going to show you that. But let me back up to Ronnie's point. So here we are in, by the way, your hands-on lab environment. So it's just great. Ronnie and I have been using Cisco's Viral for a lot of the demonstrations in Encore because we have a Viral license, but it's so great that you have gear right in the IT Pro TV library for you that you can jump on. So this is a real device, just like the Viral's a real operating system, but this is a device inside of the practice labs. And let's just actually do a quick show ver so we can see what device we're working with here. So this is a nice 3750 from Cisco. And when we do a show, what is it? Show Mac. Oh, it varies.
Address dash table. Yep.
Is it?
Address dash table.
Yeah. Why isn't it liking that? Let's see.
No dash in between the Mac and
Ah,
address.
thank you. It varies from device to device. Yeah, it drives you nuts. So there's the MAC address table. So that's the CAM table, the content addressable memory, but there's a faster mechanism, and that's the TCAM. The TCAM, that faster mechanism, it's tertiary something.
Henry, yep.
Yeah. So is it ternary?
Ternary.
Yeah. I just always call it the TCAM, right? So the TCAM is that faster mechanism for doing that switching decision. And this is where we can get into a little bit of configuration. Your switch is going to be set with some limits on the TCAM, and you want to use this command, the show SDM prefer command, to see what template is in use for the TCAM, for its like max values. So look at this. This is so interesting. I do a show SDM prefer, and it says you're currently in the desktop default template. So this switch is tuned for just the normal operation of getting all these desktops onto the network. And it says, okay, you can see the constraints, the maximum values here that are set on this device. So the maximum number of unicast MAC addresses is 6,000. Whoa, should be more than enough. But notice, like with IPv4 policy-based routing ACEs or access control entries, there's been no reservation for that. It's like, well, that wouldn't be utilized in this type of template. for just default desktop access. So what you can do is you can go in global configuration mode and you could do SDM prefer, I believe. This is another command that we don't have to do that much of. SDM, so I had a typo. SDM prefer, there we go. And my context sensitive help shows me the templates that are on this switch that I could set in order to change the default characteristics of what's possible with the TCAM. This is one of those like CCIE things, by the way. So I think I won't get in trouble for this. It was like one of my first CCIE attempts where in the switching section, it was something to the effect of tailor your switch so that it's really tuned to do layer 3 routing. And I was just like, what is it talking about? The CCIE lab exam is the worst place to learn about a feature. You'd kind of like to know about it. And this is what it was talking about. It wanted me to go in and do SDM prefer routing. So now what I just did was I told this device, look, how we're using you in our enterprise is to do a bunch of high-speed routing for us. And that is going to change these values in the template. We will for sure get IPv4 policy-based routing ACEs, and we'll get 500 of them, by the way, when we set this. So I just did set it, and notice it's telling us, all right, in order for that to take effect, you need to do a reload. So I am now reloading that 3750 so that it is up and active for us with that new template. So this is something rarely done, but note, this is a configuration that we would make potentially in order to tune this device for its role in the enterprise. And I would definitely know this.
Now, once we actually do something like this and we reload this, does it add in any extra commands into what we have?
No, that's a great point. So this didn't influence the command set that we're working with. This is just tuning the architecture for the device's role in the enterprise. I wish we had something like this, Ronnie. You know, when we come into IT Pro TV, I wish we could kind of preset, all right, I need to study today. Give me the study template. That would be nice.
Yeah, so while we're actually reloading, why don't we go ahead and do this, to our viewers. It would just look like that we snapped our fingers and it'll be done, but it may take a little bit of time for a device to reload. So what we're going to do is just do that. We're going to do just a very brief timeout and we'll be right back. Oop, just like I said, it's just a blink of an eye, but there it is. The router is now actually kind of rebooting at the end here. And Anthony, we are back, so show us that it actually did take place.
Yeah, let's make sure of this. And by the way, that's a very, you're sitting there with much trepidation in the CCIE lab exam anytime you have to reboot one of your devices, right? Make sure you've got your AAA set up correctly, because I could imagine, in fact, this has happened. This has happened. The student has to do something like this. They've messed up their AAA, they reboot the device, and they've locked themselves out. They just failed.
Yeah.
And that proctor is not going to help them get back in. So make sure that doesn't happen to you. For those of you thinking about the CCIE lab exam, look at that, Ronnie. We are now no longer the desktop default. We are the desktop routing template. And we can see that these numbers have changed. So it is tuned now for fewer unicast MAC addresses than before and a ton of routing information. So we're getting the reservations in the TCAM for all this great routing stuff.
Now, before we close out of our episode here, I have one last question. Does this affect the performance of the switch?
It won't to the naked eye. That's a great question, Ronnie. So to the naked eye, it doesn't. But yeah, it is affecting the performance. If we were to go in and really measure the performance of the device, we could see an impact, and that's why we would do it. Hey, tune yourself to routing versus tune yourself to switching.
All right, Anthony, thank you again for helping us to understand those different concepts here. We've been talking about Cisco Express forwarding and some of the different tables and the nature of how those things actually work together. Make sure you review this episode to understand the differences between the fib and the rib, the TCAM and the CAM, and of course the ARP and the adjacency table as well. There's a lot that we went over in this episode, but there is also more to come, so stay tuned for that as well. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.